Hello and welcome to this kind of full topic summary of the entirety of AQA GCSE Maths. So this is absolutely everything you can possibly be asked to do in your AQA GCSE Maths exam. Is this for higher or foundation people? It's for both. So if you look at here, these are all the spec points you can have with example questions. If there is no kind of H on the screen, then that's foundation only, and later on you'll see that there's a big HT that I'll put next to topics that are higher tier only. That's what the HT stands for. So just so you're aware, foundation people, you only need to do anything that doesn't have a HT and a circle next to it, and higher people, you need to do everything. Whether it has a HT or not, you need to know how to do absolutely everything on this video. Now, just before we get into it, just in terms of how we've divided this, I've divided it into the main 7 topics, so number, algebra, ratio, geometry, probability, statistics. The reason why it's not broken up into different papers is because technically speaking, any topic can appear in paper 1, 2 or 3. Technically. Now yes, in the past, paper 3 tends to have more stat stuff in it, paper 2 tends to have more of the trigonometry stuff in it, but just keep in mind that they can put it in any of the papers. Iteration is another one that we normally see in paper 2. However, there's a video I did previously on an iteration question. You should look that up if you want to. That was actually a non-calculated question, even though it was iteration. So just be aware that the way you should use this video is to go through it and kind of mentally make a note of what topics you may need extra help on. Again, I've got some example questions to help jog your memory, but if you're really stuck, then you'll need to go and see the appropriate video for that. But without further ado, let's get into it. So the first one, we have the number topic. We have N1. You need to be able to order positive and negative integers, decimals, and fractions. So I picked a question that has fractions and decimals in it. And you need to also use the symbols equals to, not equals to, less than, greater than, less than equal to, greater than equal to. So how would I put these in order? Well, there's a few things you can do. You can turn the fractions into decimals, or you can turn the decimal into a fraction and then make sure they all have the same denominator. So keep in mind, it's very difficult to compare fractions and decimals without converting them into each other. So for example, if you wanted to change 3/4 into a decimal, what you would do is you would do your good old-fashioned bus stop method. You'd stick a 3 on the inside, so the numerator goes inside the bus stop and the denominator goes outside, and then you divide. Well, 4 doesn't go into 3, so we put 0 there. The remainder would be 3, so we're going to add on a 0, put a 3 there, put a dot. How many times does 4 go into 30? Well, 4, 8, 12, 16, 20, 24, 28. It goes in 7 times with a remainder of 2. So we put a 7 there, add the remainder on the end. How many times does 4 go into 20? It goes in 5 times. And you can use that to calculate the decimal version of any fraction. In this question, however, and again, I'm assuming it's a non-calculator question. If you have a calculator, then obviously that makes it a lot easier. We're actually going to turn these all into fractions because there's only one thing we have to convert. So how do I change a decimal into a fraction? Well, it's quite easy. We have 3 decimal places after. So what we're going to do is we're going to write those unique decimal points and we're going to put them over 1,000. Why 1,000? Because there's 3 zeros for the 3 points after the decimal point. Then all we're going to do is simplify this as much as possible. So we can, for example, divide it by 5. We can divide it by 25 as well. So 25 into 725. That's something we could do. So that should be 714, 28. It should be 29 over 1,000. Or if we divide it by 5, we would get, divide by 10, double it, we get 145 over 1,000 would be over 200. Divide by 5 again, we would get 14.5. Double that would give me 29 over 40. So 29 over 40. This one, if we change it into over 40, we can times the top and bottom by 4. 7 times 4 is 28 over 40. Times this one, top and bottom by 10. And the reason why I've picked over 40 is because A, I see that this fraction here becomes over 40, and B, this one here is 40. So the lowest common multiple between all of these denominators is going to be 40. And that will give us 30 over 40. And this last one's obviously 31 over 40. Now we can put these in order. So, in order, the smallest numerator will be the first value, and then you'd go on from there. So the smaller the numerator, the smaller the actual value. And then all you do is you write these in order, but keep in mind you need to write the original value. So this would be 7 over 10, first one, then 0.725. So you need to write it in its original form. Then you would have 3 over 4. And lastly, you have 31 over 40. Okay. Now keep in mind in the description I've actually put timestamps so you can jump between the different major topics, so between number, algebra, ratio, etc. But again, I would recommend just at least skimming through the video, put it on 1.5 times speed if you have to, just to make sure you cover all the spec points and tick them off as you go along. There is going to be a kind of study planner at the end of the video that I'll go through at the end, which will kind of help you. It'll have all of the different spec points, you can tick them off as you go along. Next one, it says apply the 4 operations including formal written methods to integers, decimals, simple fractions, mixed numbers, and all positive and negative. So what I've done here is I've picked probably the most difficult ones from either. So first of all, I'm assuming with integers you're able to times, divide, add and subtract. Again, you can just use column method, but with decimals it might get a bit tricky. So with multiplying, or indeed dividing, what we're going to do is actually remove the decimal places, okay? You can't just chuck this straight into the column method and get the correct answer. So I'm going to remove that one, 1 to the right, so that's 1, and I'm moving this one 1 to the right, 1. So overall, I've moved the decimal places 2 to the right, and that's going to be really important later on. So now I'm going to do 7 times 34. So the best way to do this is to do column method. 7 times 4 is 28, so put the 8 down here, put the 2 on top. 7 times 3 is 21, plus the 2 gives me 23, so we're at 238. Now of course that's not my answer. Because I've moved the decimal point 2 to the right, I need to move the decimal point 2 to the left in my final answer. So the actual answer is 2.38. Okay. So again, that's how it works in terms of doing multiplying of 2 decimals, and I've also shown you how to multiply integers as well, right, because we changed them into integers. With division you're actually going to do pretty much the same thing. So if I wanted to kind of go backwards in this sense, I could do, let's say, 2.8 divided by 7, right? And what you do here is you would times the top and bottom by 10, or maybe just times the top one by 10, which gives us 28 divided by 7, which is 4. But because I've moved the decimal point 1 to the right here, I need to move the decimal point 1 to the left here. So the answer is 0.4. Okay, now with fractions, I'm going to show you again the fairly trickiest example. So when you add or subtract, all you need to do is make the denominator the same by multiplying, and then add or subtract them respectively. With multiplying, well, I'm actually going to show you multiplying as well, because remember with division, you do KFC. You keep the first fraction the same, you flip the second fraction, and then you change the division to a multiply. But the first thing you do, if they give you a mixed number, is you change it into an improper fraction. So to do that, how do I change this into an improper fraction? Quite easy. You do the whole number times the denominator, so 4 times 4, which is 16. Then you add on the top number. So 16 plus 3 is 19 over 4. And now we do KFC. We keep the first fraction the same. We flip the second fraction. And then we change the divide to a times. And when you times fractions, you literally just times the top numbers and you times the bottom. So 19 times 5, well, I know that 20 times 5 is 100. So it should be 5 less than that, which is 95. And 4 times 3, of course, is 12. Now you can change this back into a mixed number if you want, and I'll just show you how to do that quickly. All I do is I work out how many times 12 goes into 95 entirely. So 12, 24, 36, 48, 60, 72, 84, and then it would be 96. So it's 7 times in total, and the remainder is 11. So 7 and 11 over 12. Okay. And again, with adding fractions, let's say you just, I'm going to pick a fairly easy example, a half plus a third. you need to make, and this will be the same for subtract, you need to make the denominators the same, so find the lowest common multiple, so I can times them by each other, top and bottom. Remember, anything you do to the bottom of a fraction, you must do to the top. So that becomes 3 over 6 plus 2 over 6, which equals 5 over 6. Okay, nice and easy. For the next one, you need to essentially be able to use BIDMAS. So you may have heard this be called PEMDAS or BODMAS or something along those lines, but the idea is still the same. The B means you do brackets first, right? So I'm going to write BIDMAS just because I'm in the UK and that just happens to be the one that we do. But again, with PEMDAS, you know, instead of B for brackets, it's P for parentheses, and then you have O for order instead of indices, etc. But with this example here, this does come up fairly frequently, and it will come up as parts of questions as well. So there may be a question where you just happen to write out something like this, and you need to be able to do the operations in the right order. So the first thing you do is the brackets. So I resolve anything that's inside brackets first, which in this case is just 3 plus 2, which is 5. So that's what this equation now becomes, right? The next thing, the I do any indices next. Well, the only indices I have is here, 5 squared. 5 squared is just 5 times 5, which is 25. Then D stands for division. I don't have any division in this question. M stands for multiplication, which is 25 times 2. So that's 50. A is addition, so you'd add things next. Don't have any of that. And S is for subtraction, which brings us to our final answer. These questions float around like Instagram and TikTok quite a lot, where they give you like something like this, and then people argue about it in the comments. Just always remember BIDMAS, and then you can like flex on random people on the internet if you really want to. But that is that, okay? Just need to make sure you do these first. Now, one question I do get asked is where do things like square roots and cube roots fit into here? Well, both of these are indices. So you do them in the same time that you do any indices, okay? So they're the same thing as squaring, for example. Here we go. Here's a fun one. So, use the concepts and vocabulary of prime numbers, factors, multiples, common factors, common multiples, highest common factor, lowest common, blah, 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 all of this stuff. So firstly, we need to go through what the words prime, multiple, and factor means. So a prime number is a number that has 2 factors, okay? And what is a factor? A factor is a number that divides into another number with no remainder. So for example, the factors of 16. So what can I divide 16 by and get no remainder? Well, 1, right? 16 divided by 1 is 16. 2, 16 divided by 2 is 8. 4, 16 divided by 4 is 4. And then 8, and then also 16. So a prime number is one that has 2 factors, which is why the number 1 is not a prime number, because the only factor of 1 is 1. That's one factor. 2 has 2 factors, right? I can divide it by 1, I can divide it by 2. And these are kind of the first few prime numbers, but honestly, with practice, these kind of come a bit obvious, and the next one will be 19, for instance, then you have like 23, and so on. And then what's a multiple? Well, a multiple is a number that is essentially part of another number's times table. So the multiples of 3 are just the 3 times table. Multiples of 2 would be the 2 times table. Multiple of 1 is just counting. Multiples of 5 is the 5 times table, and so on. Okay? Okay, that took quite a bit out of me there. Now with the highest common factor, what we have to do is do something called prime factorization. Now that sounds really fancy, but it's just a factor tree. So what we're going to do is we're going to do factor trees for 75 and 105. Now again, in questions, generally speaking, they'll say, write 75 as a product of its prime factors, and you'll do a factor tree. And then they'll say, for part B, find the highest common factor of 75 and 105. You have to do the same thing. So let's see, 75. What can I divide it by? Well, 5, because it ends in a 5. So let's do 5. And to divide any number by 5, you may have seen me do it relatively quickly. I just divide by 10, which gives me 7.5, and then double it, which is 15. And then lastly, we can do 5 and 3. And I'm going to circle the numbers that I can't divide anymore. If you notice, these are all prime numbers, hence the word prime factorization. I've just written 75 as a product of prime numbers. It's 5 times 5 times 3, which is the same as writing 5 squared times 3. Now I'm going to do the same thing with 105. Again, it ends in a 5, so I'm going to divide it by 5. There may be another number I could have divided by, but that's the one I'm choosing for now. And again, divide it by 10 gives me 10.5. Double it will give me 21. Then you have 7 and 3. Okay? And again, this is just our list of prime numbers. So the question is, how do I work out the highest common factor? So the biggest number that goes into 75 and 105. Well, now all you need to do, and bear in mind, lowest common multiple and highest common factor are very similar, but they're different. Okay? All you do is you highlight the numbers that are common. So I have 1 5 here, 1 5 here. So I'm going to write 5 down here. I have 1 3, 1 3. So I'm going to put times 3. There is nothing else that's common, right? The 7 is unique, and this other 5 is unique, as in it's only in one of them. That will now be my highest common factor. So sometimes in questions you may have, let's say, 5 cubed here and 5 squared here. Then you would put 5 squared times 3 instead. You're looking for all of the numbers that are common between 75 and 105 and multiplying them together. So all the common factors they have multiplied. So hopefully that makes a bit more sense. And now for the LCM. So the method is very, very similar. We're going to do prime factorization for 120 and 144. So let's get to it. So 120, again we could divide by 5, or we can divide by 10. And again you will get the same answer, so don't worry about which one you do. This one will become 5 and 2. Highlight, highlight. And 12 will become 4 and 3. I probably should have put the 4 on the other side, but yeah, that's fine. And honestly, the most common mistake I see with this type of question is that students don't write all of the numbers they have, or even they misread a number. I've seen students read a 2 as a 7, even though it's their own handwriting, which is, it's a bit funny, but at the same time it's a bit tragic. So this could be 5 times 2 times 2 times 2 times 3. Okay, now we're going to do the same thing for 144. So you might know that 144 is just 12 squared, so you can break this up in 12 and 12. If not, you could divide it by 2. And then 4, 3, all a bit tight on space, 2 and 2. And this would be the exact same thing as well. And again, I should have done the 4 on the other side, but don't worry. The reason why I'm saying that is just because I have more space. It's not actually because it changes the working out. Okay. Now this is where things get a bit funky. There are a few ways to represent this, but my personal favourite is using a little bit of a Venn diagram. Times 3, cool. Okay, so here is what I would personally do. I would do 2 little circles, right? And you want a big old overlap between them. You might know that this is called a Venn diagram, which is wonderful. And what we're going to do is any values that are common, so we have a 2 here and a 2 here, you can put in the middle of this because they're shared. And you can then multiply them together. The other way to look at this is to just, as I highlight them, I'm going to write down what I've highlighted. So I've highlighted 2 times 2. There is another 2 that's common, so 2 and 2. So I'm going to do times 2 times 2. Okay. There's another 2 that's common. So I'm going to do times 2 times 2. There's a 3 that's common. So I'm going to do times 3 times 3. And lastly, you're going to do you're basically just going to times by any number that you haven't times by already. So I've already times by this 2 and this 3, right? I've already times by 2s and 3s. But there is another unique number, and that is a 5. So I'm going to times it by 5, and that will be my lowest common multiple. So the reason why this is a bit more tricky is probably the last step. The highlighting them, that's fine, right? Like 2 and 2, so I times them together. 2 and 2 times them together. 2 and 2 times them together. 3 and 3 times them together. That's fine. But the last step is you times by any number that you haven't already multiplied by. So you can the way I word it is that you times them by the remaining multiples. And then this particular question would have been in a calculator paper. So we're just going to whip out our calculators. We're going to do 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 5, which is 2,888, which is the lowest common multiple. Don't know why I wrote run. The lowest common multiple between 120 and 144. Okay. Hopefully that's all okay. It's going down a little bit. Let's move this a bit further down. We are. For part 5, you have to apply systematic listing strategies, and here's the first higher tier component that you need to do. So again, all of you higher students should have been listening to the rest of this, but this is specifically for you, so foundation people, you can turn your brains off for a second. You need to apply systematic listing strategies and use the product rule for counting if you're in higher tier, because sometimes you won't be able to list all the possibilities out. There might be 1,000 possibilities, in which case, good luck, right? So, I'm actually going to combine it into one question. In this question, it says list all the possible pairs of cards. We're also going to work out how many pairs we should have. So, logically, 2 can match with 5, 6, and 8, right? 5 can match with 2, 6, and 8. 6 can match with 2, 5, and 8, and so on. So each card has 3 possible partners, right? So I know I'm going to times by 3. I times that by how many cards I have. Because again, each card will have 3 possible cards to pair with. It can't pair with itself. And so on. So 1, there should be 3, plus another 3, plus another 3, plus another 3, which is 4 times 3. So we should have 12 combinations. So even if you're in foundation, it can be helpful to know how many you're supposed to have, so that way you can double check your answer, because it's very easy to lose track. So in terms of systematic listing, basically they don't mean just do like 2 and 6, then 8 and 5, then 6 and... Like, you have to have some kind of system, some order to it. So the way I would do it is I'd start with all the 2s. So 2 can match with 5, 2 can match with 6, 2 can match with 8. Then I move to the next card. 5 can match with 2, 5 can match with 6, 5 can match with 8. Now you're probably going to ask a very good question. Isn't 2 and 5 and 5 and 2 the same thing? Well, yes, but the only time you'll be expected to make that distinction is if it says list all of the possible unique pairs of cards. Unique meaning that they're different every single time. Okay? So for example, if I'm like putting my hand in a jar of sweets, right? And I know there's 5 blue and 5 white and 5 red as well. Getting a blue and a white sweet is the same as getting a white and a blue sweet, right? Doesn't really affect me at all. But in terms of all the possible pairs, 2 and 5 and 5 and 2 are different. Okay? If they say unique possible pairs or possible unique pairs, then you would not include the ones that have the same actual cards in it. Then we have 6 and 2, 6 and 5, 6 and 8. And then you have 8 and 2, 8 and 5, 8 and 6. There is one other exception, which is essentially where they may have a selection of coins. Like someone has 2 20p coins, 3 50p coins, and a pound coin. How many different totals can they get? Then, of course, getting a 50 and a 20 is the same as getting a 20 and a 50. So there's, you would have to discount that as well. And if you look, 3, 6, 9, 12, we get the full thing. So even if you're foundation, it won't get more complicated than this, which is good. If you're higher, it does get sometimes a bit bigger. So instead of having just 4 cards, they could have 50 cards, and they'll say, okay, I have 50 cards, how many combinations is that? Well, there's 50 cards that you have, and each can match with 49 other cards, so 50 times 49. But for foundation, you do not need to worry about that, but it's good to be able to check your answer. Here we go. Part 6. Using positive integer powers and associated real roots, so square, cube, and higher, you need to be able to recognise powers of 2, 3, 4, and 5. So what I've done is I've listed all of the ones that commonly come up, okay? Because I'm very nice. And you also need to be able to estimate powers and roots. So basically kind of get in between. So you should know all of the square values from 1 until 13. By recognise, I mean if you see the number 169, you should know that's 13 squared. If you see the number 144, you should know it's 12 squared. Just instinctively. As you practice, this will become easier. With cube numbers, again, you should be able to do these in your head, but keep in mind, it's very easy to work out, right? So if they gave you like the square root of 144, you could go up in your square numbers until you get to 12. If they gave you the cube root of 64, you could go up in your cube numbers until you get to 4. So on. With cube numbers, you should know up until 5 cubed. Again, this is just what's commonly been asked, right? So I have researched all of the papers, and these are the ones that I kind of think you should know by heart. The 4 numbers, which very rarely come up, you should know up until 3 to the power 4. And lastly, the 5 to the power 5 numbers, you should know 1 to the power 5 and 2 to the power 5. That's pretty much it. Technically speaking, 2 to the power 6 sometimes comes up, but in the spec it is only 2, 3, 4, and 5. Now, in terms of the estimating powers and roots of any given positive number, they may say to estimate something like square root 97. Now if I look at the square root numbers, I didn't actually go that high, but I know that 10 squared is 100, and 9 squared is 81. So if I were to estimate square root 97, I would say it's approximately 10, because it's really close to 100. It's far closer to 100 than it is to 81. Okay. You also need to be able to calculate with roots and with integer indices. So that's basically this section for those of you in foundation. If you're not in foundation though, and you're in higher, you also need to be able to use fractional indices and negative indices and all that fun stuff too. And the way that works is as follows. So the first thing I would do with a question like this, and this has come up a fair bit, is I'll tackle the negative first. So when you have anything to the power of minus, so let's say you have 2 to the power of minus 1, you do 1 over 2. So I can write this as 1 over 32 to the power of 3/5. Now the negative is now gone. So what does a fractional indice actually mean? Well, what it means is that you're taking the denominator root of the number, so in this case the 5th root of the number, yeah, and the numerator means you're taking that power of the answer. Now technically speaking, you can do these either way around. You could do 32 cubed and then take the 5th root. The problem with that is a big number, an ugly number, and it's quite hard to work out on a non-calculator paper. So I would always recommend doing the denominator first, which means you're taking a root of a number. So it could be, in this case, it's the 5th root. And if you remember, 2 to the power 5 is 32, so this is just 1 over 2 cubed. And if you remember, 2 cubed is 8. And again, to work that out, it's just 2 times 2 times 2. But hopefully that makes sense. I would always tackle the negative first. And again, to be honest, the questions are very similar each year. So you put 1 over. Then whenever you have a fractional indice, what you're doing is you're taking the denominator's root of the number, so in this case the 5th root, and then you do the numerator as the power. So in this case, you cube it. So this part of the spec here, we need to be able to calculate exactly with fractions and with pi. So essentially they may ask you to leave your answer as a simplified fraction or in terms of pi. Now with the higher tier stuff, we have to actually use surds, which are basically just square roots, and we need to be able to simplify them and also rationalize denominators. So what this part means here is whenever we have a surd in the denominator, we always have to rationalize it. So we can never have a surd in the denominator. We need to make sure we fix that issue. In fact, if you look over here at a calculator, if I did something like 1 over root 2 and just press the equals button, you might notice that your calculator actually rationalizes for you. You are not allowed to have a square root on the bottom of a fraction. So how do we do this? Well, in this case, when we want to simplify things, all we do is we split them up into two separate values, one of which should be a square number. So 150 we could simplify to, we could pick 25 because that is a square number, and that would be times 6. Right, that's one thing we could do. 6 we can simplify as square root of, actually no, we can leave it as square root 6 to be honest, over square root 2 times square root 3 gives me square root 6. Now square root 25 times 6 is the same as having square root 25 square root 6, and now hopefully you might be able to see why I said that we need to pick one of the numbers to be a square number, because now square root 25 is just 5. So this is equal to 5 root 6 minus root 6 over root 6, which is why we need to make sure one of the numbers is a square number, which means that gives me 4 root 6 over root 6. And here we could times top and bottom by a square root, or we can actually just cancel it straight away like this. So it equals 4. However, to rationalize denominators, you just times top and bottom by square root 6 and simplify from there. With part 9, you need to be able to use standard form, again, higher and foundation, and you need to also be able to calculate with them. So something like this. So again, this is probably going to be a non-calculated topic. So how do you do a division such as this? Well, with timesing, adding, timesing and dividing especially, all you do is you divide or times the beginning number and then divide or times the times 10 part together. So 1.8 divided by 3 is 0.6. Again, the way you can do that is to do 18 over 3, which is 6, and then move the decimal point back beforehand. And that will be times 10. And remember, when you divide indices like this, you actually subtract them. So we're doing 10 to the power of 2 minus 1, which is 3. Now this isn't actually standard form yet, because standard form needs to be between 1 and 10 in front. So that's going to be 6 times 10. So what I've done here is I've times this number by 10, so I'm going to divide this one by 10. So that'd be 6 times 10 to the power of 2. So again, when you're timesing or dividing, you times and divide the decimal number in front, and then you times or divide the powers separately. If you're adding or subtracting, you have to turn them into ordinary numbers, do the add or subtract, and then turn it back afterwards. Here we have to work interchangeably with terminating decimals and their corresponding fractions. So again, things like that. But then you also need to be able to convert recurring decimals into their corresponding fractions and vice versa. So we need to here change this into a recurring decimal. So the way you would do this is do good old-fashioned bus stop method. 6 into 5 doesn't happen, so we put full stops there. The remainder will be 5. Now we have 6 into 50, which is going to be 8. Right? And so 6 times 8 is 48, so that'd be a remainder of 2. 6 into 20 is 3, and the remainder is also 2. And then can you see that I'm just going to get the same thing on forever? So 5 over 6 is just equal to 0.83 recurring. And then I'm sure you've seen the other questions, we have to go in the opposite direction as well. So how would I convert 0.83 recurring into this kind of decimal? Well, you can do it in a few different ways. One of which is to say that, so they may give you like a decimal here. They might say that convert 0.83 into a fraction. Well, all you need to do is you say x is equal to this recurring decimal, and then you would take 100x or 10x to be honest, either one's fine, and that would give me 83.3 recurring. So when I subtract these two from each other, we'll get a whole number, and then you divide it over nice and easily. Identify and work with fractions in ratio problems. So, for example, a is half of b, so here you'd write that as a is equal to 1 over 2b. So work out the ratio of a to b. Well, in this case, you would have a being, so if you times this out, you have 2a equals b. So the ratio of a to b would be 2 to 1, because you have a 2 here and you have a 1 in front of this number. You should also be able to interpret fractions and percentages as operators. So when they say, for example, take a half of 80, you should know that that means you're basically timesing. So you're doing a half times 80, so you just do 80 divided by 2 and then times by the numerator. So in this case it would be 40. And the same thing with percentages. Percentages are also operators, so 20% of 60 just means 20% times 60. I want to show you a little trick that a lot of students don't know, but there is a percentage button on your calculators. So if you do 20 shift answer times 60, it will automatically do 20% of 60 for you. Now, again, that works if you're in a calculator test, of course. If you're not in a calculator test, what I would do is either A, convert to a fraction and work it out. So 20% is a fifth times 60. So you're doing 60 divided by 5 times by 1, which would be 12. You could also use the calculator, as I've said, or you can work out 10% by dividing by 10, which gives you 6, and then doubling it. You have a bunch of different ways to do it. Here, use standard units of mass, length, time, money, and other measures, including standard compound measures, while using decimal quantities where appropriate. So standard units of mass are going to be kg and g, so you need to be able to use them. Length would be meters, centimeters, kilometers. Time, seconds, hours, days, minutes. Money, pounds normally. Compound measures would be things like speed being meters per second, density being grams per centimeter cubed or kilograms per meter cubed, and you also would have speed and also acceleration as well. And pressure, that's the other one. Part 14, you need to be able to estimate answers. So check calculations using approximation and estimation, including answers obtained by technology. So sometimes they'll say, Sam says that this is equal to a very specific decimal. Using estimation, test if that answer is correct, or they may literally just say, use estimation for this, something along those lines. So here is what I would do to make my life easier. Whenever you see estimate, you're going to round everything to one significant figure. Okay, this is always accepted in your mark schemes, okay? And it's the easiest way to do it. Can you round to other things? Absolutely. If you want to think about it a bit more, you can round it to different values if it makes sense to, but in my experience, rounding everything to one significant figure makes your life a lot easier and it's always accepted. So for example, root 97 to one significant figure would be square root of 100. 2.014, one significant figure would just be 2 cubed. And 0.49 would just be 0.5. So, square root of 100 is 10. 2 cubed is 8 over 0.5. So that equals 18 over 0.5. Now 0.5 is a half. So if we're dividing by a half, then you're just doubling it, which would make 36. Nice and easy. So again, they may just literally ask you to estimate, or they may say, check Tim's calculation. You know, Timmy does a calculation on a calculator. He gets this number. Check using estimation if it's correct. Anything along those lines. It will say estimate. Whenever you see estimate, round to one significant figure, and the maths becomes a lot easier. You also need to be able to round numbers and measures, which is a bit obvious considering I just told you need to be able to round. But it comes after that in the spec, so that's the order I've done it in. To an appropriate degree of accuracy, so either significant figures or decimal places, and use inequality notation to specify error intervals, which we're actually going to do down here. It's marked as higher, but to be honest, it's the same thing for higher and foundation. So number of people living in a town is 47,000 to the nearest 1,000. Which one of these is a possible number of people living in this town? So if they've rounded to the nearest 1,000, the smallest it could be is 46,500, because this would round up to 47,000, and the biggest it could be is going to be just under 47,500, so technically 499. If you look here, the only one that fits that criteria is this. The way I would actually do this question is I'd round all of these numbers to, in this case, the nearest 1,000. So underline the number. Is the number next to it bigger than 5? If not, the number stays exactly the same. In this case, the number is bigger than 5, so we add 1 to the number, and so on. This will be 48,000. This will also be 48,000. Cool. So, error intervals. Apply and interpret limits of accuracy and also do upper and lower bounds. Technically speaking, this is only for higher, but error interval is very similar to the stuff they do in Foundation 2, so there isn't much difference in that sense. So when rounded to 3 significant figures, x is 6.37. Circle the error interval. Here's what you do. You take this final decimal point, so that's 0.01, right? Because that's the position it is, and you half it, which would be 0.005, and you add or subtract it. So the biggest value is 6.375. That's the biggest number. And then I subtract it, which would be 6.365. And that is going to be my value, and that is the error interval here. Nice and easy. And if you notice here, it can equal 0.365, but it cannot equal 375, because obviously that would round up to 38. That's it for number, so we're about a seventh of the way through. Hopefully you haven't fallen asleep. Again, feel free to put this video on speed 2 or kind of break it up into chapters, go to the bits that are relevant to you, do anything. But you need to do a bunch of algebra. How fun. So you need to be able to use and interpret algebraic notation. So for example, timesing two things is the same as just writing the two letters next to each other because we're lazy, right? We don't need to write the multiplication. Adding 3 of the same letter can be replaced with 3y or 3 times y squared in terms of this, and so on. So in this case, here are some questions that could be asked. I might say, so the expression that equals to x plus x plus x minus x plus x. A lot of students get this wrong. So x plus x, 2x, 3x, back down to 2x, back up to 3x. A lot of students put 4x, which annoys the living daylights out of me. Lucy wants to simplify 4a minus 7b. Well, simplify this to get 4a minus 7b. Is she correct? Well, here's how you tell. What I would do here is actually do it for myself. Okay? Now, with brackets, whenever you have them, you have to multiply out by everything outside the bracket. So in this case, we have 6a. Now this minus is multiplying the 7b and the minus 2a. So minus 1 times 7b would give me minus 7b. Now minus times minus 2a would be plus 2a, which gives me 8a minus 7b. So she is not correct. Okay, you have to be very, very particular when it comes to these types of questions. Whenever you have brackets, the thing outside the bracket, whether it's a minus, whether it's a 10, whether it's a 400, multiplies everything inside the bracket. This also counts if you have double brackets, right? So a bracket and a bracket touching, the first bracket multiplies everything in the second bracket. Okay? So keep that in mind. However, if this was written the other way round, where you had 7b minus 2a minus 6a, there's no multiplying here. Okay? The brackets can just go away. It has to come before the bracket. So the next thing that we have to do is we have to be able to substitute numerical values into formulae and expressions, including scientific formulae. So we'll come on to the actual formulas a bit later on, but we just need to be able to substitute things into algebraic expressions. So for example, in this question it says work out the value of a squared minus 4a when a is equal to 10. So all we need to do is everywhere we see a, we're now going to put 10 in brackets. So we're going to have 10 squared minus 4 times 10. 10 squared is 100, and minus 40. So our final answer is 60. Nice and easy, okay? But they may have multiple things too. There may be an A and a B or something like that. But just remember, always put it in brackets, and it will make it a lot harder for you to go wrong in the exam. And if you have a calculator as well, using brackets will stop your calculator doing dumb things that you don't intend it on doing. So understand and use the concepts and vocabulary of expressions, equations, formulae, inequalities, terms, factors, and including identities. So, first of all, what is an expression? An expression is something that has multiple terms in it. So, for example, you might say something like x plus 2y. That is an expression because it has at least one term in it and an operation as well. So there needs to be at least one operation, otherwise nothing's really happening with it, okay? So in the first question we did in the algebra section, it was x plus x plus x minus x plus x. That's an expression. Now with an equation, all you need to remember is it has to have an equal sign. That's it. So the only difference between an expression and an equation is one of them has an equal sign in it. So if you have an equal sign, it's an equation. If you don't, and like I said, you need to have more than one term. So essentially the way I remember it is you need to have at least one operation. So if you see a times, divide, add or subtract, so don't forget 2y is also a times, right? Then it's an expression. If it's just one thing by itself, then it's a term. And if it has an equal sign, it's an equation. A formulae is a special type of equation that tells us how to work something out. So for example, one equation that you're going to be able to use is pressure is equal to force over area. And again, in your GCSE science as well, pretty much every equation that you use in science is actually a formula because it tells you how to work something out specifically. This thing here, I could just work out numbers and it doesn't really mean anything. But here I'm actually working out a thing, right? I'm working out pressure. I'm working out something that has a meaning in real life. Same with, for example, weight equals mass times g, gravitational acceleration or gravitational field strength. These are formulas because they basically calculate something. Inequalities, it's actually quite easy. It's just when something isn't equal. So again, you could have x plus 2y, and then you're going to have one of four symbols. You can have greater than z, you can have less than z, you can have greater than equals to z, you can have less than equals to z, and lastly you can actually have not equal to. All of these, again, where all of these can replace this one here, are inequalities. And lastly, factors, we actually did that a bit earlier. It's just a number that can divide into another number perfectly. So here we have a chunky spec point. You need to be able to simplify and manipulate algebraic expressions by collecting like terms, multiplying a single term over a bracket, taking common factors out, simplifying expressions involving sums, products, blah, 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 blah. So let's start with that first. So we need to be able to multiply out brackets. Now, generally speaking, they ask you to expand and simplify. So we're going to be doing that a bit later on as well. So when you multiply out brackets, don't forget the thing outside the bracket multiplies everything inside the bracket. So we have 5x times 3x, 5 times 3 is 15, x times x is x squared, and then you have 5x times minus 2. So 5 times minus 2 is minus 10x. Nice and easy. Now what about factorising something? Well, factorising is the opposite of expanding or multiplying out. All you're going to do is we're going to put this into brackets. So the thing what I asked myself is, what's the biggest number I can take out of 50 and 100? In other words, what's the highest common factor of 50 and 100? Well, they can both be divided by 50, and that's as big as it possibly could be. So I'm going to put 50 here. Now look at the x's. Can I take out an x from this term and this term? Well, the answer is no, because there's only an x in the first value, not in the second one. So I'm going to put a bracket now and do x, because 50 times x is going to be 50x, and then what do I times 50y to get to 100? I times it by 2. So continuing on, we have simplifying and manipulating algebraic expression, but this time it could be with two brackets instead of just kind of a single number on the outside. So we need to be able to factorise these and expand them, which I'm going to show you over here. So although this is a higher topic right here, it's actually going to be, the first part is going to be useful for foundation as well, because I'm going to show you how to expand double brackets. So factorising a simple quadratic. Simple quadratic just means that there is just a 1 in front of the x squared. There's not a minus, there's not a 2, there's not a 10, whatever. All you need to do is you're looking for two numbers. They need to multiply to give the last digit, 10, and they need to add to give 7. So what I do here is I look at my factors of 10. Well, I have 10 and 1. Can they add or subtract to give me 7? Nope. Okay, what about 5 and 2? Can they add to give me 7? Yeah, so I'm going to use the numbers 5 and 2. Okay, and then all I do is I put those in my brackets. X plus 5, x plus 2. Now, the beauty of factorised questions is you can always check your answer so you know if you've got it right by expanding the brackets again. So if I go back to this question, 50 times x gives me 50x, 50 times 2 gives me 100. So I know 100% guaranteed that I'm right. Now, how can I do that with this? Well, we're going to expand and simplify these double brackets, which basically hits 2 spec points in one because I'm cheeky. So, how do I do expanding double brackets? Well, there's a couple ways to remember it, but essentially everything in the first bracket has to multiply everything in the second bracket. So you need to do x times x first, which is x squared. Then you need to do x times 2, which gives me 2x. So that finishes this first term here. Then I need to do 5 times x, which is 5x. And then 5 times 2, which is 10. So the thing that I'm going to kind of remind you of is that whenever you expand double brackets, you should get 4 terms here. But if you notice, I actually have 2 lots of x. I have 2x and 5x. That means I'm able to collect like terms. Like terms have to either have no x's, 1x, x squared, x cubed, etc. They need to have the same power of x. So x squared, I don't have any others, so I'm just going to write x squared. 2x plus 5x would give me 7x. So you just add the numbers in front, and then plus 10, which gives me my original answer, my original question, which means my answer is correct. So again, that's how you do it with expanding and simplifying. The other way you can use to remember this, so again, I just want to point out that all you need to make sure of is that the first term multiplies both of these and the second term multiplies both of these. So everything should multiply everything else that's in the other bracket. One way that some people like to remember this is using something called FOIL. F stands for first, so you multiply the first terms in each bracket, x times x. O stands for outside, which means you multiply the things on the outside of the bracket, so x and 2. You may have noticed I actually followed this order instinctively. I stands for inside, so you multiply the two things on the inside of the bracket, so 5 and x. And L stands for last, which means you multiply the last terms in the bracket, 5 and 2. But again, it's not necessary. If you have a different method of remembering, that's totally fine. So expanding triple brackets is where things get a bit more spicy. So expanding all three of these at once is quite tricky because you need to times everything in the first bracket by everything in both of the other brackets. And a lot of people make mistakes. So here's how I would do it personally. If you're a machine and you're able to actually remember to do that, then follow your method. What I'm going to do is I'm going to expand 2 brackets first, and you can pick whichever 2 you want, and then expand the third one later. So if I expand just the first 2 brackets, I need to leave them in brackets because they're going to times the last thing. X times x is x squared, again using FOIL first. Outside, x times 4. Inside, 2 times x. Last, 2 times 4. And then I leave the x plus 1 out there because it's still one of the terms. Now I'm going to collect like terms. X squared plus 6x plus 8. Now here, you need to do the same thing as we did in the first question. We're going to expand a double bracket, but if you notice, there's actually 3 terms in the first bracket. So I need to times x squared by both these things, 6x by both of these things, 8 by both of these things. So in this case up here, you should get 4 terms. In this case, you should get 6 terms. If you remember that, you can kind of spot any mistakes you make. So x squared times x gives me x cubed. X squared times 1 gives me x squared. Right, so I've done the first one. If you like, give yourself a little tick once you've done one of the values, and that can kind of help you keep track. So if I've ticked this off, and it makes sense because I have 2 terms here, because there's one thing here and there's 2 things in this bracket. So each of these should give me 2 terms. 6x times x gives me 6x squared. 6x times 1 gives me 6x. So again, I've done another 2 terms, so I tick that off. 8 times x gives me 8x, and 8 times 1 gives me 8. So I'm going to tick that off, and now I know I'm done. So that's like a little trick I use to kind of keep track. So especially when I'm teaching in front of a class, it's easy for me to make a mistake on this. So I tick it off as I go along, just to make sure that I have all of the terms that I expect. Now the last thing you want to do is simplify by collecting like terms. So whenever they say simplify, they just mean collect like terms, at least in expanding questions. So this simplify here just means collect the like terms once you're done. So x cubes, can you see any other x cubes? I can't, so I put x cubed. And what I'll do in the exam is I'll do a very faint line through there. Now of course I'm on a computer, so it's harder for me to do a faint line, but with a pen, if you do it very lightly, it will help you keep track of the ones that you've done. I'm going to use a tick just because if I do it in pen, it's just going to smear everywhere. X squared, well I have x squared and 6x squared, so that gives me 7x squared. So I'm going to tick those off. Again, I would just do a little light line through the term. You don't want to cross it out because then your examiner will think, okay, they want me not to mark this. But if you do a very light line, they can kind of say, okay, it's just for their working out to keep track, which is smart. Then 6x plus 8x would give me 14x. So I'm going to tick those 2 off. And then I have 8 on the end, which obviously I can't do anything with, so I'm just going to leave it as plus 8. Nice and easy. Now, factorising, when the number in front isn't 1, there are a couple of things you can do. The first thing you do is see if you can simplify it, which I can't, right? If I could divide the whole thing by 2, that'd be great, but I can't, so I'm not gonna. So here's what you have to do. You do a very similar method, but it's a lot more complicated. I'm still looking for 2 numbers that add to 5, right? So they add to that last number. But they're not going to times to 2. They're going to times to 2 times 2, which is 4. Okay? So again, just go over that. Instead of timesing to the last number, adding to the first and adding to the middle one, they times to the last number times the first number. Okay? So times to 2 times 2, which is 4. So I'm looking for 2 numbers that times to 4 and add to 5. Well, it looks pretty obvious to me, but 4 and 1. And now what you do is you replace 5x with 4x plus 1x. So instead of 5, we're just writing the numbers 4 and 1, essentially. So we have 2x squared plus 4x. And it doesn't matter which order you write them in. So if you put the x first and the 4x second, you'll get the same answer in the end. Don't worry too much about it. And then what I'm going to do is I'm going to split this in half. Okay? So I'm going to factorise the first 2 terms first. So what's the biggest thing I can... So again, because we have x's and numbers, I take it step by step. What's the biggest thing I can pull out of 2 and 4? Well, they're both even, so I can factorise out 2. Now I have x squared and x. So what you want to take out is the lowest power of x, which is just x. Okay? So for argument's sake, if this was x to the 4 and this was x squared, I can take out x squared because it's the lowest power. You just look for the lowest power. It's super easy. In this case, the lowest power is just x. Then open bracket. I have 2x. I want to get 2x squared. Well, if I want another x, I'm just going to times it by x. I have 2x and I want 4x. Well, I'll times it by 2. Not too bad, right? Now, I'm going to factorise the last thing. Now, if you notice, x and 2, there's nothing that I can take out. Now, for this kind of scenario, all you do is you factorise out a 1 because you can divide them both by 1. The reason why we're doing this is because I need some form of bracket. So even if I can't take out anything, I'm just going to take out 1. Okay? Perfect. Now, if you've done this correct, the 2 brackets you have, the two brackets you have, the two brackets you have should be the same. Okay? So in this case, one of our brackets is just going to be x plus 2 because it's the duplicate bracket. If you don't have the same bracket, let's say the sign's different or I have an x plus 1 instead, I've done something wrong earlier on, okay? I need to look at that. So another thing you can do when you're looking at this factorising here is say, okay, it needs to be the same as the first bracket. What can I take out? Well, plus 1 would give me the same bracket, so I'm just going to take out plus 1. Your second bracket is going to be everything that's in front of each of these brackets. So I have a 2x and a plus 1. If you wanted, you could expand this bracket out just to double check your answer. So I'm going to leave that to you to do. So if you want to check the method for checking, which sounds a bit weird, expand this double bracket here and see if you get this first answer here. And again, don't forget, all of this stuff here, this triple brackets and the factorising with a 2 in front of the x squared is higher tier only. So, next one, understand and use standard mathematical formulae. So you, for example, v equals u plus at, areas of triangles, Pythagoras' theorem, etc., etc. And you need to be able to rearrange formulae to change the subject. So, how do I do this? Well, when it says make the subject, all you're doing is you're getting this letter by itself on one side of the equation. So our final answer will look like u equals and then a bunch of stuff. Okay, making x a subject here, I'm going to have x equals and a bunch of stuff. Now rearranging, making the subject formulas, questions, almost tripped over my words there, tend to be pretty tricky. I tend to get asked how to do them a lot. The best way to do them is to practice, okay? But I'm going to show you some common tricks you can use. Because believe it or not, although there are an infinite number of formulas they can ask you to rearrange, their actual layout is all the same. They may give you a fraction where x is in the top and the bottom, or whatever letter they're asking you to rearrange for. They can make that a q, right? Different formula, but it's the same question, right? So, this is probably one of the easier types. If I look at what's stopping u from being by itself, on this side of the equation, it's the plus at. So what I need to do is do the opposite of plus at to make it by itself. The opposite of adding is subtracting, so I'm going to subtract at. Now the key thing to remember here is whatever you do to one side, you have to do to the other. Now v minus at, can I actually work out what that is? No, so I'm just going to leave it as v minus at. Now u plus at minus at will just leave me with u. So that's my answer. U is equal to v minus at. Now for x, this is a bit more tricky. Why? Because we have a fraction. So here's my order of operations. If there's a bracket, expand it. If there's a fraction, get rid of it. Those are my orders of operation, okay? If I see a bracket, I terminate it with prejudice. If I see a fraction, I get rid of it because all my homies hate fractions, okay? So how do I get rid of a fraction? Well, the best way to get rid of a fraction is to times it by its denominator. Okay? So if I times this right-hand side by x plus 2, I'll instantly get rid of the denominator, which means there's no longer a fraction. So for example, if I look at a half, if I times a half by 2, right? Well, it gets rid of the denominator, right? Hopefully that makes sense. So I'm going to times both, and again, whatever I do to both one side, I do to the other. So I'm going to times both sides by x plus 2. So that gives me, how shall I write this out for you? Alright, I'm going to do it in a very short steps because I want to make sure you understand it. Some of you watching may be able to do this a lot faster than what I'm doing. That's totally fine. And on the right hand side, we just have x plus 4 because again, timesing a fraction by its denominator just deletes it. And remember what I said about brackets? Terminate them. ax plus 2a equals x plus 4. Okay, now some of you may spot that there's a bit of an interesting part of this question in the sense that we have x's on both sides of the equation. So how can I get x equals? Here's what you do. If you have multiple things with x in it, doesn't matter if it's 2, 3, 4, 1,000, you bring them all to one side. Which side do you do? Doesn't matter. Although your final answer will look slightly different, both will be accepted in the mark scheme. So don't worry, they are actually the same. Okay, it's just that the signs may be different. I'm going to move this x to the left-hand side, and to move anything, all I do is I do the opposite. So this x is positive, so I'm going to subtract it. So we have ax minus x plus 2a. Please keep in mind that you can't actually subtract ax and x. Not technically speaking, okay? Okay, so I'm not done yet. I want just x's on one side, right? Because I want x equals. So I'm going to move everything that isn't an x to the other side. Now, I can't move this a. I can't move it yet. So what I'm going to do is I'm going to move the 2a. That says plus 2a. So using my big brain, I'm going to subtract 2a. Okay, and I'm going to continue from up here, okay? So ax minus x plus 2a minus 2a, that just leaves me with ax minus x. And 4 minus 2a just leaves me with 4 minus 2a because I can't actually solve that. Okay, now how do I make this 1x? Well, I do factorization. So here's the order if you have multiple terms that you want to kind of rearrange for. So in this case, I have multiple x's. Bring all the x's to one side, then you factorize out the thing you want. I don't want a, so I'm not factorizing out a. I don't want minus 1, I'm not factorizing now. I want x. So what I'm going to do is I'm going to put x and a bracket. I'm not even going to think about it yet. Okay, what do I times x by to get ax? Well, a. What do I times x by to get minus x? Well, minus 1. And now, for my last trick, I just divide both sides by the new bracket that you have. Now remember, if you can't do a division, you leave it as a fraction. So I have 4 minus 2a divided by, so fraction, a minus 1. There we are. Bish bash bosh. Easy peasy. Again, practice these. Please practice them. If you would like me to go through some more of these, then just leave a comment and of course I'll go through them. But again, it's just all practice. Okay? Keep calm, and honestly, as long as you follow the rules of maths, so whatever you do to one side you do to the other, and you divide things properly, you add and subtract things properly, and you times things properly, you'll never get this question wrong, right? You'll be able to get some marks. Just don't do anything naughty, okay? For those of you doing higher tier, you have the privilege of doing proofs, which is really exciting. Now, in terms of what proofs they can give you, there's like a billion, so I'm just going to show you a few tricks. So prove algebraically that the sum of any two consecutive integers is always an odd number. So, if I want to pick a generic number, and that's the point of algebraically, right? So if I wanted to prove this to you normally, I'd say, okay, well, consecutive means they're next to each other. So 1 plus 2 is 3, that's odd. Okay, 2 plus 3 is 5, that's odd. Okay, 3 plus 2 is 5 as well. I just went the wrong way. 5 plus 6 is 11, that's odd. Okay, but the thing is, that's not good enough for mathematicians. Right? Because all I've done is I've selected like 4 cases and said, well, it's true for all of them. But that doesn't always work. And you've probably seen the questions where it says, you know, Jacob says this, give an example to prove that he's wrong. So what mathematicians have to do is they have to use algebra. Because if you use algebra, that proves it for every value in existence. Okay? Which is really important, because otherwise you would have to prove it from minus infinity to plus infinity, which will take you a really long time. So, how do I denote an integer? Well, I'm just going to use the letter n, right? If we have a number that we don't know, we just call it x or y or n or whatever. And it doesn't matter which letter you use. I'm just going to use n because I am. Now, how do I denote the consecutive integer? Well, how do I go from 1 to 2 and 2 to 3 and 3 to 4? I add 1. So the consecutive integer would be n plus 1. Now it's saying, prove algebraically that the sum of any two consecutive integers is always an odd number. So n plus 1 equals 2n plus 1. So how can I show that this is always odd? Well, two things. One, whenever we want to denote odd numbers in proofs, we actually write 2n plus 1. But that's not good enough for this question. Why do we say 2n plus 1? Well, it's because this is always even. Think about it. 2 times a whole number is always going to be an even number, right? 2 times 1, 2 times 3, 2 times a million. They're all even. And what happens when you add 1 to an even number? It's always odd. So always odd. when you add 1 to an even number. Now this is actually a 3-mark question, and I really don't find it to be that tricky. And again, well, yeah, maths teacher talking, right? But hopefully you can kind of see the logic. Unfortunately, this is a lot of problem solving and logic, but you can cheat. You can mimic it. What I mean by that is you can just do a bunch of questions on it. I have got a live stream lesson of proofs and an edited version on my channel, so you can have a look if you'd like. We do a bunch of them ranging from like the lowest to the easiest all the way to the hardest, so it might be interesting to you if you want to check it out. Okay, where appropriate, interpret simple expressions as functions with inputs and outputs, interpret the reverse operation as the inverse operation, and interpret the succession of two functions as a composite function. So both of those are higher, but the first thing is, if I have a look at this, there is an input, which is the mileage, and the output is the actual taxi fare, right? Cool. So it says, work out how much a 10-mile taxi journey would cost. Well, it's going to be £2.50 plus £2.20 per mile, so that's 2.20 times 10. So that is £2.50, whoops, plus 2.2 times 10 is 22. So that is £24.50. Perfect. Now for you higher tier lot, you have to do functions with inverse functions and composite functions. So a composite function is just when you basically do two functions in a row, or you substitute one function into another. So, given that f of x is equal to x squared minus 3, solve f of minus x is equal to 8. So there are a few ways to do this, but I'm going to show you how to work out an inverse function because I think that would be a fairly useful thing to do, but there are other ways to do it. So to work out an inverse function, instead of f of x, you write y, and you write out the function again. And what I'm going to do is I'm going to rearrange for x, because remember, an inverse function takes in x values and gives out, so a regular function takes in x values, gives you y values. An inverse function will take in y values and give you x values. So you need to make x the subject. So add 3 to both sides will give me y plus 3 equals x squared, which means x is equal to the square root of y plus 3. So as an inverse function, I would write that as, instead of x, I'm going to write f of minus 1x. Instead of y, I'm going to write x. And that would be the final step. Cool. Now it's saying solve that this equals to 8. Well, okay. X plus 3 equals 8. I'm going to square both sides, which gets rid of the square root on the left-hand side. 8 squared is indeed 64. So x is equal to 61. Now find GF of 3. Cool. You do the last function first. So I'm going to work out f of 3 first. Now f of 3, if I sub in 3 here, is 2 times 3 minus 4. So that equals 6 minus 4, which is 2. You take that answer and sub it into G. So what this is actually saying, GF of 3, is it's saying do f of 3, whatever that is, put into G. So I'm going to do G of 2 because I know that f of 3 is equal to 2. And that gives me 3 times 2 plus 5, 6 plus 5, which is 11. Nice and easy. Well, to be fair, it is a pretty tricky topic, I'm not going to lie. This isn't too bad of a question. Again, I have got functions as a live lesson, so most of these topics I have as live lessons if you want to practice. We do a bunch of exam questions, and since there are students asking me questions, hopefully they ask questions that you might be stuck on yourself, so you can kind of get a benefit there. Lastly, work with coordinates in all 4 quadrants. So coordinates always come as pairs. There is an x value and a y value. So for example, 1, 2 tells me I go 1 along the x-axis, 2 up the y-axis. So I'd go 1 here and then up 2. So that coordinate would look somewhere, dang it, there we are, like that. Okay. Now why do they say in all 4 quadrants? Well, if you notice, if I look at the quadrants here, the top right quadrant, which is sometimes called the first one, is all positive, right? We have positive x and positive y. Now if I go to this quadrant here, sometimes called the second quadrant, x is negative and y is positive. So you might have something like -3 and 4. So I go -3 along and I go 4 up. So that's what they mean. That's getting annoying, isn't it? That's what they mean by being able to use coordinates in all 4 quadrants. Bottom left, sometimes called the third quadrant, you have both values being negative. X is negative and Y is negative. And lastly, in the fourth quadrant, or the last quadrant, whatever you want to call it, you have a positive X and a negative Y. You just need to be able to plot coordinates in all 4 points. So if I gave you the coordinate 5 minus 3, would you know where to plot that on the graph? If not, you need to practice that. If you do, wonderful. So 5 across, -3 down. Okay. Following straight on from that is plotting graphs of equations that correspond to straight line graphs, and using the form y equals mx plus c to identify parallel lines and find the equation of the line through 2 points, and do y equals mx plus c to identify perpendicular lines if you're higher tier. So first of all, let's do the plotting. Now, be warned, the straight line's probably going to not be so straight. But generally speaking, they'll give you a table of values. If they don't, I'd recommend constructing one. And all you're doing is you're substituting in these x values and seeing what the y value is. So for the first bit, -2, I'm doing y is equal to 4 times -2 minus 4. So 4 times -2 is -8. Sorry for the closed bracket there. And then -4 will be -12. And the next one will be y equals 4 times -1 minus 4. -4 minus 4 is -8. Now, here is an interesting little trick, if this is easy for you. This number in front of the x tells me how much y increases each time. So I can actually fill in the rest of these. It's -4, 0, 4, 8. Because all I'm doing is like a sequence, right? And if you remember arithmetic sequences, they look something like that. They go up by 4 each time. In this case, the number in front of x is 3, so it goes up by 3 each time. If it was a -2, it goes down by 2 each time. So you don't have to sub in every single value. You can use that little trick where you'd find the first value, let's say -12, and you say, okay, the number in front is +4, it's a positive, so I'm going to add 4 each time. And if you want, you can just quickly check any of the answers here. And yeah, it should be fine. Now, how do I plot these? Well, each of these values gives me a coordinate, so each pair. So this is actually the coordinate -2, -12. This is the coordinate -1, -8. And if you notice again, the x values go first, y values go second. So -2, -12, I'm going to have to scroll down a little bit for this. I go -2 on the x-axis down to -12, and I put a little x. -1, -8. Go along to -1, down to -8. Put a little x. 0 and -4. 0 is always along the, well, in this case, is along the y-axis, and -4, so it'd be here. Right, you have to actually put it on the axis line itself, and if you notice, it is looking like a pretty straight line. 1 and 0. 2 and 4. 3 and 8. So again, all of these are just making coordinates for me. Like this. Okay, x number first, y number second. And it has to be each pair, of course. And then all you do is you draw a straight line going through these. Now, shall we see if I can actually successfully draw a straight line? Probably not. Yeah. Well, let's do it freehand. Again, use a ruler. Don't do what I'm doing. Okay, I messed up the last bit. But hopefully you can see my point. You'd have a straight line going straight through those. My points are plotted perfectly, but my straight line with my crippled old hands isn't working very well. So, for higher end foundation, you need to be able to spot parallel lines. So, when two lines are parallel, it means they never get closer to each other and they never get further away. They stay completely equally distant from each other. The only way for that to happen, for parallel lines, is for the gradient to be the same. So when two lines have the same gradient, they are parallel. 100% of the time, guaranteed. Okay? So, how do I tell what the gradient of a line is? Well, you use the equation y is equal to mx plus c. M, so the number in front of x, is the gradient. The number at the end is something called the y-intercept, which is basically the y-coordinate when it touches the y-axis. So if you look here, we have -4, and if you look, my line crosses the y-axis at -4 because it's the y-intercept. To intercept someone is to cross them, right? To meet them somewhere. So, hopefully that all makes sense. If I look at this equation, the gradient is equal to 3, right? Now, I want you to be very careful. If I had something like 2y equals 4x plus 2, is the gradient 4? No, because of this. There can be nothing in front of the y. There can't be minus, there can't be divide by 4, there can't be times by 17. You have to divide everything by 2, which gives you y is equal to 2x plus 1. So the gradient is actually 2 instead, okay? So if I write down an equation of a line that's parallel to this, all I need to do is make sure that the number in front of x is 3. The number on the end can be anything. Doesn't matter what you put. It can be minus a third, plus 10 billion, whatever you want to do. Now, for the higher peeps, what about perpendicular? Well, when two lines are perpendicular, it means they cross at an x, okay? At 90 degrees to each other. So, their gradients are negative reciprocals, okay? What does that mean? Well, it means, so the gradient of this line is equal to 3. So if I take the gradient of the perpendicular line, is going to be 1 over 3, and then I flip the sign, make it negative. Okay? So, you do 1 over. If it's a fraction, you just flip the fraction. If it's just a number, you put 1 over it. And then you change the sign. So if it was minus 3, it would be plus a third. If it was 2 over 3, it would be minus 3 over 2. And so on. And it says just write down any equation. So, all I need to do is make sure the number in front of x is minus a third. And again, I can do anything. Sometimes they say you have to make it a specific point, and then you deal with it as and when you come across it. But in this case, we don't need to do that. Identify and interpret gradients and intercepts of linear functions graphically and algebraically. So here it says find the gradient of L, but it says also intercepts in the spec point. If you look here, that's the intercept. So the y-intercept is, in this case, I would say 0.5. The x-intercept, when it crosses x, is negative 1. Okay? Now, how do I work out the gradient of a line? Well, here's what I do. I'm going to draw a dotted line going down and a dotted line going across. And I do it such that they will meet. And what I do is I count how many squares it goes up by. So 1, 2, 3, 4, 5. It's 5 squares up. How many squares across is it? 1, 2, 3, 4, 5, 6. Oh god, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's 10 squares across. All I do is I divide those two numbers. So the gradient is, and when I say divide, you always do the y value first, the height first, over 10, which is of course 1/2. Now there is one exception to this rule, is what if the graph was actually going down? Well then if I did that, I would still do the x and y. So this goes 3 and 3, and m would be 3 over 3, which is 1, right? Wrong. If the graph is going down, you have to make it negative. If the graph is going up, you leave it positive. If it's going down, you make it negative, okay? So down equals negative. Up equals positive. Always, okay? Next. I promise you algebra is probably the longest section, so after this we've actually got a few really short sections. Statistics is only 6 points, for example, so under half what algebra is. So identify and interpret roots, intercepts and turning points of quadratic functions graphically, deduce roots algebraically, and deduce turning points by completing the square. So again, if you have a quadratic, it's going to look like a U or an N shape. The turning point is just, so if I do a lightning fast sketch. Quadratic looks something like this, right? This is the turning point. Again, the intercepts are the same thing. The y-intercept would be here, and the two x-intercepts are over here. Now, you might have noticed that it also says roots. Well, for quadratics only, roots equals x-intercepts. Why do we call them two different things? Well, it's a bit of an annoying thing, but essentially it's because the equation equals 0, and roots is another word for solutions. So solutions, when the graph equals 0, is also called a root, which graphically is just an x-intercept. So 3 words that all mean the same thing. I love maths. But, yeah. X-intercepts, again, is just where they cross the x-axis, y-intercept where it crosses the y, and the turning point, which is the only new thing really, is where it turns, right? So either the peak or the bottom of the kind of trough that you have. Now, for you higher tier people, you get to work out, and you're so lucky, you get to work out the coordinates of turning points by doing something called completing the square. So here's how you do completing the square. Here's the generic formula. X squared plus bx plus c. You do x plus b over 2 squared minus b over 2 squared plus c. That might look absolutely heinous right now, but let's use this as an example. B is the number in front of x, and c is the number at the end. So I have x, and what's b divided by 2? Well, 14 divided by 2 is 7 squared. Minus b over 2 again, 7 squared. Again, you need to use brackets, because keep in mind, this is always going to be negative, right? Because if you square the negative number, you get positive, but you make it negative anyway. Okay? So keep that in mind. Then plus 52. So that, now we have to simplify. 7 squared is 49. 2. Whoops. Plus 3. Okay, so what are the coordinates of the turning point? Well, the turning point is actually the smallest value that this equation can be. So I'm going to explain it first, and then I'm going to show you the little trick. Okay, but I think that remembering tricks is hard if you don't know what the methodology behind it is. So, what is the smallest thing this bracket squared can be? Well, think about it. If it's positive, I square it and it becomes positive. If it's negative, I'll square it and it becomes positive. Right? But if it's 0, it will be 0. So the smallest thing this can be is 0. And then I'll add 3. So, all you do to work out the coordinates of the turning point is you flip the sign of this bit. So in this case, I make it minus 7. And I just keep whatever's on the end exactly the same. Why? Because to make this value as small as humanly possible, right, because a turning point is just the smallest possible value, I have to sub in x equals minus 7 to make this 0. And then I add 3. Okay? Perfection. And now we get on to a bunch of recognizing, sketching, and interpreting different functions that you need to be able to do. So we've already done linear and quadratic, and hopefully those make sense. Quadratic are U-shapes and N-shapes. Linear are just straight lines. Now we also have cubic and reciprocal functions. So here's what a cubic graph tends to look like. Okay, and this is basically the most basic form that they should give you. It looks kind of like half of a DNA, so to speak. But again, in a more advanced case, they could give you something that looks more like this, that. So it either has like 2 humps, or it kind of just goes to 0 and goes back up. For the other type, it says the reciprocal function. Now the reciprocal function looks like this. And the key thing to note here is that it never touches either axes. It just gets really damn close to them. Okay? So it's either going to look like that, or it's going to have kind of the same shape on both sides. But this is what the generic reciprocal function looks like, okay? But again, if you ever have these kind of exponential looking decay things, then you should know that it's going to be a reciprocal function. If you are a higher tier student, you have a few more that you have to do. You have to do y equals k to the power of x. This is nice and easy. It just always looks like this. So it's kind of rapid increase, like the world population. For the trig functions, again, should be fairly easy. You're going to have sin x and cos x. So This one here will be sine. And again, this is for every kind of 90 degrees. So keep in mind the arguments have to be in degrees because you don't know any other one yet. And it varies between +1 and -1. Okay? With cos, you're basically just taking this and actually shifting it over to the left if you wanted to do something like that. So you can click this, and you go doots like this. So it starts off at 1 and it goes down to 0, and then it goes back up. Okay? And if you are doing the trig function, this is where it looks very different indeed. I'm just going to try not to rub out my axes accidentally. The trig function looks kind of like the cubic one, but it repeats continuously. So just to show you what it looks like, I'm going to start from the negatives, even though you don't have to start from the negatives. It looks kind of like this. Where this value here, which is 90 degrees, is an asymptote, which means it's never going to touch, the curve's never going to touch it. And this is minus 90 degrees. And then you're going to have the same thing again. Except this one here is at 270 degrees. This is at 180. And so on. Okay, so every 180 degrees it's going to have this kind of snaky shape. And yeah, I know that's not perfect, but that's kind of roughly what it's going to look like. Now for higher tier only, you need to be able to translate and reflect any kind of function. So here I've kind of drawn it out for you. Now the key things to remember here is that if the thing is on the inside, it affects x and it does the opposite. So what this means here is you're going to minus 3, because it says plus 3, from x. So this is a translation. Literally what you'd do is you'd pick up this U shape. So if I draw this out, and instead of it being at 1, 4, it's going to be at 1, 1. So it's going to look roughly the same, but it's going to be shifted over slightly, where this is now 1, 4. Actually, one sec. If I shift it over a bit more, it might make a bit more sense. So we're minusing 3 from x. So instead of 1, 4, it's going to be minus 2, 4, which is going to be on this side over here. So you're literally just picking up the graph and you're just moving it over to the left. Okay, cool. For minus f of x, this is actually your first reflection. If it's outside the bracket, it affects y, and it does exactly what it says. So I'm actually just timesing y by minus 1. So instead of 1, 4, we actually have 1 minus 4. Now what this actually looks like is a reflection in the x-axis. Okay. So instead of it going up like this, it's actually going to go, and again this is going to look horrific probably. But remember, you don't have to be Michelangelo here, okay? You can keep it relatively simple. And that's going to be 1 minus 4 instead. Okay? So again, the whole thing flips upside down. So can you see here, this first part is now above the axis, this middle part is all below, and this last part is above the axis again. So rub that out. Whoopsies, almost ruined everything. Again, if it's outside the bracket, you're going to be doing exactly what it says and it affects y. So in this case, we're going to be minusing 3 from y. So instead of 1, 4, it's going to be 1, 1. And again, this is a translation. If you add or subtract from every single coordinate, you're just going to be moving it up, down, left or right. That is a translation. Whereas a reflection is obviously going to actually change the overall shape. So what this is going to look like is instead of it being up here, it's going to be a lot lower. So you're going to have something that might look something like this. Again, the shape, it's important you keep the shape, obviously, but you don't have to be like super duper accurate with it. And lastly for the last one, that's a bit obvious. F of minus x, again, you do the opposite. So in this case, it's timesing x by minus 1. So you're basically dividing x by minus 1, but hopefully you can see that that's actually the same thing as timesing by minus 1. So instead of it being 1, 4, it's going to be minus 1 and 4. And what this does is it reflects in the y-axis. So basically everything on the right is now going to be on the left. Overall, that's actually not really going to change the shape much, is it? Because if you remember rightly, quadratic functions are symmetrical, so it isn't actually going to change what it looks like by that much. So I'll try and make it like less steep or something to make it seem that way. But yeah, it's going to look very, very similar. Okay. For the next one, and again, this is, you have to do this, if you're in higher, you have to do the same thing but with exponential graphs. So they may show you things like depreciation or something like that. But for all of you, you need to be able to plot and interpret graphs and graphs of non-standard functions in real contexts to find approximate solutions to problems such as kinematics or distance, speed, acceleration. So here it says Bernie is filling up a swimming pool. The graph shows the volume V of water in the swimming pool at time t. Work out the rate that the water is flowing into the pool. Give your answer in litres per hour. So in this case, they're actually asking us for the gradient. If they ever say the rate, that just means gradient, because it means how quickly is y changing with x, which in this case is volume against time. So if I, again, when you're finding gradients, it's helpful to find points that are going straight through a point, right? So we can maybe use, this one looks pretty good. The width of this would be between 12 and 16, so it would be 14. And the height, if you see it, is going to end up here. So that should be 6,200, sorry, 62,000, 64, 68, 72. Nah, it's too big. So it should go up in, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the difference is 29. It goes up in 2,000, yeah. So 62, 64, 68, 70, 72, 74, 76, 78, 80,000. So that's going to be halfway between that. It would be 72,000. So the difference is 72,000 minus 20,000, which is 52,000. So the answer is just 52,000 over 14. Now this is actually a calculator question, so I'm just going to pull up my calculator, and you're just going to do 50, whoops, that's a 3, divided by 14, which gives me an answer of 3714 litres per hour. Okay. And it does say volume in litres. Got there, that's fine. Calculate or estimate gradients of graphs and areas under graphs, including quadratic and other non-linear graphs. Graphs is just losing meaning for me at the moment. And interpret the results in cases such as distance, time, velocity, time. Okay, so when you have a velocity time graph, the gradient gives you the acceleration, and the area will give you the distance. So to work out the acceleration for the first 3 seconds, again, basically a triangle. This side is 3, difference between it is 3, so you're doing 3 divided by 3, and because the line is going up, it's a positive answer. So the answer is 1 meters per second squared. Now working out the total distance is where things get a bit more spicy. What you can do is just find the area. So there's 2 ways to do this. You can break this up into like a triangle and a rectangle or something, but if you look, this is actually one big trapezium, right? Or I can turn it into a trapezium and a rectangle. So let's do a trapezium and a rectangle. So that side's 2, this side is 5, this side's 3. Now the width of this rectangle here, it goes from 3 to 7, so the width is 4 and the height is 5. So what we're going to do is the area of a trapezium is a half a plus b, so that's the 2 parallel sides, so 2 plus 5, times the width, so the height, which is 3. And you're going to add on 4 times 5. Okay, and again we can kind of just do this on a calculator to be a bit cheeky with it. So 0.5 open bracket 2 plus 5 3 plus 4 times 5 gives me 30.5. Perfect. Meters. Okay, and moving swiftly on. Recognize and use the equation of a circle with the center at the origin. So here's the equation for a circle, right? It's x squared plus y squared equals the radius squared. So in this case, the radius is 5. Our equation of a circle would be x squared plus y squared equals 5 squared, which is 25. Okay, So if you have x squared plus y squared, it's always going to be an equation of a circle, and it just equals whatever the radius is squared. So if you want to work out the radius, you just square root that number. Now, here is where things get a bit more interesting. The diagram shows a circle of radius 5 centimeters with the center of the origin. Find the equation of the tangent to the circle at 3, 4. So 3, 4 is right here. So, right. Now, if I were to draw a tangent, you might notice I'm not caring about doing it with a straight line. Why? Because in a lot of exam questions, you don't get an accurate drawing anyway. So I'm going to show you how to do this without doing an accurate drawing because I'm a nice guy like that. So, the key thing to remember is that the radius and the tangent are always perpendicular to each other. So if I work out the gradient of the radius, I can inverse reciprocal it, so negative reciprocal it, to find the gradient of the tangent. So I'm going to write mr for radius. So it ends up at 3, 4. So it's going to be the change in y, which is 4, and it starts off at 0 over 3 minus 0. So it just equals 4/3, which means the gradient of the tangent is negative 3/4. So I flip it and make it negative. And that should make sense because the line is going downwards, right? Kind of makes sense. Okay, so my equation of the tangent now is y is equal to minus 3 over 4 plus c. Why? Because again, remember the equation of a straight line is y equals mx plus c. Now if you notice, they give me a set of coordinates. So I can sub those in. I'm going to do this all the way up here just to give myself some more space. I'm just going to sub those in. So x is equal to 3, y is equal to 4. And again, this will help you in the earlier question. Remember when it said work out lines that are parallel and perpendicular to each other. Sometimes they don't give you what plus c is, so you have to work it out. Just use a set of coordinates and sub in the x and y value. So, sorry, that should be an x after here. I'm getting a bit lazy. So y is equal to minus 3 over 4 multiplied by 3. That shouldn't be a y. Okay, I need to slow down a bit. So 4 is equal to negative 3/4 times 3 plus c. So 4 is equal to minus 9 over 4 plus c. Add 9 over 4 to both sides. So 4 plus 9 over 4 equals c. So 4 is just going to be 16 over 4. So that is 25 over 4 is equal to c. So the actual equation of the tangent is y is equal to minus 3/4 x plus 25 over 4. Which looks about right because it should cross above 5. So I'm happy with that. Cool. For part 17 of algebra, we have to solve linear equations in one unknown algebraically and also be able to find solutions using a graph, including those with the unknown on both sides of the equation. So you could have something along the lines of if x, or like 3x plus 7 equals, let's make it nice, 28. And they can say solve for x. So in this case you would subtract 7 from both sides and then divide by 3 to get x equals 7. Okay, so you need to be able to do this even if there are kind of unknowns on both sides of the equation. So a similar question could be something like, and you may notice this is actually the same question as the last one, so you can actually have a go at this yourself and see if you get x equals 7. But you need to be able to do this repeatedly, and it is one of the core kind of pieces of maths. They really want you to be able to use algebraic equations and solve them, and they're just linear ones. Again, this mostly comes from practice. Finding solutions using a graph, again, they can give you a graph which has a straight line like this, and they may say, you know, solve it when it equals 0, for instance, in which case you're just looking for the x-intercepts. We have done this in the previous parts, so hopefully that already makes sense from then. Part 2. Solve quadratic equations by factorising and also find approximate solutions using a graph. The next part says including those that require rearrangement and also using completing the square or the quadratic formula. So just to go through these in order, completing the square we've gone through in a previous part to find the turning points. You can do that as well to work out what x is by square rooting. But the quadratic formula is if you have a generic quadratic equation that looks like this, and again it has to equal 0, that's why they're talking about the rearrangement here. You can only solve a quadratic when it equals 0. So if this had a 7 on this side, or an x, or an x squared, or whatever, you need to get rid of it, move it all over to one side. The quadratic equation would be as follows. Minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, and you just sub in the values in front until you get the correct answer. So we're going to solve this in a few different ways. I'm going to show you how to do it in all three ways. The first one is by the absolute classic method of factorization, right? So we're going to do this one first. All you need to do is factorize the quadratic in the method that we described above. So two numbers that times to 10 and add to minus 7. So in this case, both of them are going to be negative, and you're going to get x minus 5, x minus 2 equals 0. Now the only way for this to actually be true is if one of these brackets is 0. So either x minus 5 equals 0, or, in this case is actually and, x minus 2 equals 0. So x is equal to 5, x is equal to 2. Those are our two solutions, okay? That is one way to work it out. The next way is using the good old-fashioned quadratic formula. Now you don't actually need to write this out, but I'm going to write it out just so you guys are completely aware of what's happening. A is the number in front of x squared, b is the number in front of x, and c is the number on the end. So here we would have minus, and for the love of God, please make sure you use brackets, because if you don't, and this goes to sixth form students as well, if any of you are watching this for some reason, I have had year 13 math students, really bright, doing perfectly fine, that don't use brackets and they get the wrong answer. Just make sure you use brackets. It really isn't that long, considering that, you know, there'll only be like one question on the exam that requires this. But it will prevent you making any stupid mistakes in it, and more importantly, it will prevent the calculator making stupid mistakes. To illustrate my point, in the middle here we have minus 7 squared, right? Now if I type minus 7 squared on a calculator, I get negative 49. Here's my proof. Let's open up the calculator that I had. Minus 7, whoops, okay, that's going to be a bit weird. Minus 7 squared. That's not correct. I'm actually doing minus 7 squared, as in the whole thing should be squared. So it should be this, okay? So calculators are stupid. Not just that, but at this beginning here, it's minus b, right? Now when it's a negative number, students have a tendency of writing minus 7. No, it's minus of minus 7, so it actually becomes positive, okay? Then again, you can't do plus minus on a calculator, so instead you're just going to pick one and then do the other one afterwards. So I'm going to do plus first, then minus. That's just the way I've always done it. Doesn't actually matter which way around you do it. B squared minus 4, A was 1, C was positive 10. Yep, and then that's over 2 times 1. Press equals. Oh look, I get 5. And then if I change it to a minus, what am I going to get? 2. So I get the same answers. The last one is by completing the square. Now normally they only ask you to solve it by completing the square when it's a non-calculator paper and you can't factorize it. That's the only time they do that. In that case, if you remember the completing the square formula, boy, this is fun, isn't it? We have x minus 7 over 2 squared minus 7 over 2 squared plus 10 equals 0. So solve it. Well, don't solve it yet, obviously, but squared. I'm going to use a calculator just because, bear in mind, the question I picked isn't really designed to do completing the square on. So that's why I'm just going to use the calculator to work out the last bit. To speed this up a little bit. So minus, he says as he fumbles using a calculator twice. Good lord, my fingers don't work. Minus 9 over 4. 0. Then you're just going to add 9 over 4 to the other side. I'm going to square root both sides, which gives me x minus 7 over 2 equals plus or minus 3 over 2. So then x is equal to plus or minus 3 over 2 plus 7 over 2. Now you can actually solve this because it means either x is equal to plus 3 over 2 plus 7 over 2, which is 10 over 2, which is equal to 5, or it's equal to minus 3 over 2 plus 7 over 2, which is 4 over 2, which is equal to 2. So again, there's like 3 different ways of doing it. The last way is they may give you a drawing. You know what? That is not a bad curve. Anyways, they may give you a drawing and they'll say, okay, let's say this is y is equal to, I don't know. They may say, hence solve x squared minus 10x plus 47 equals 0. And what they're trying to get you to do is relate the fact that this equation of the graph here is the same as this equation. And when it looks like it says equals g, I'm sorry, equals 0. When this equation equals 0 is when it crosses the x-axis. So then all you're doing is reading off those points. So there could be anything like, I don't know, 2.4 minus 5.6 or whatever. Okay. So those are the different ways you need to be able to kind of solve quadratic equations. Okay, next thing, we need to be able to solve simultaneous equations. Finding solutions using a graph as well. So again, simultaneous equations, when you have a graph, they will cross at a certain point here. That is your solution. Easy, super quick, super fast. They will generally give you the drawing, and all you have to do is read off the coordinate. The x value is the x coordinate, the y value is the y coordinate. Done. Easy, quick, 2 marks. However, if life is pain, instead you may be asked to do simultaneous equations by hand. So the linear ones, all you need to do is make sure that one of the terms, so y or x, has the same number in front of it. So in this case we have 3 and we have 3 here. It doesn't matter if they're different signs or the same signs. That doesn't matter so far. Just make sure they have the same number. If they do, you need to either add or subtract the equations. If they're different signs, so diff signs, you add. So if the top one's positive and the bottom one's negative, or the top one's negative and the bottom one's positive, you add the two equations. So in this case we're adding. If they are the same sign, you subtract. Okay, that is it. Okay, so first step, make the number in front the same. If it isn't already, you have to multiply an equation or divide it or whatever. Again, I do have a lesson on simultaneous equations. If they're the same sign, you subtract. If they're different signs, you add. Again, when I say same sign, if they're both negative or both positive, you're subtracting. Don't even think about it. So if I add this, I get 4x plus x is 5x. 3y plus minus 3y is 0. 18 plus 7 is 25, which means x is equal to 5. Then to find out what y is, you sub it into any of the equations that you have. So in this case, I have 2 equations, but if you had to multiply, you have more. So I'm going to just put it into the top one. So I have 4 times 5 plus 3y equals 18. So 20 plus 3y equals 18. Subtract 20 from both sides, you get 3y is equal to minus 2. So y is equal to negative 2/3. Easy peasy, 4 marks. Pretty good. Now for you higher tier people, you have to use a different method of solving simultaneous equations, especially when you have quadratics. You have to use a method called substitution. This method here is called elimination. Okay, so let's title that. And this is substitution, okay? What you have to do is the linear equation. You're always going to get one quadratic and one linear equation. You take the linear equation, rearrange for x or y, it's dealer's choice, and sub it into the quadratic equation. So I could rearrange this for y if I wanted to, or x, doesn't make a difference. So if I sub that into the first one, I have y minus 5 squared plus y squared equals 13. Expand the brackets, you would get y squared minus 10y plus 25 plus y squared equals 13. Again, I'm doing this slightly fast, just, it's meant to be for a revision video, right? So you can check off stuff. Add that together, we get 2y squared minus 10y. And I'm going to move the 13 over to this side, which will give me plus 12 equals 0. I'm going to divide everything by 2. which includes the other side. What's 0 divided by 2? It's 0. So now I'm going to try and factorize this. So two numbers that times to 6 but add to give minus 5. That is minus 3 and minus 2. So now I have y is equal to 3 or y is equal to 2. Okay, so again I did that quickly, but hopefully you can follow along if you take it a bit slower. Now how do I work out x? I have two different values of y. Good. You should have two values of x and two values of y. Remember, in a quadratic equation there's always two solutions. They might be the same answer, but there's always two of them. So I'm going to have two values for x because it's x squared and two values for y because it's y squared. So I'm subbing this into the linear equation because I'm not a masochist, and I get x is equal to 3 minus 5, which is minus 2, or x is equal to 2 minus 5, which is minus 3. So my pairs of solutions are y equals 3, x equals minus 2. And again, you want to keep them in pairs because, you know, it does make a difference. Right? If y is 2, then x isn't minus 2, x is minus 3. Okay? So you want to keep these together in a nice little box. Cool. That would be a 6-mark question. I did that in a couple minutes. Well, probably not even that if I didn't have to explain it. So again, you should definitely expect yourself to be that quick later on. Part 20, you need to be able to use iteration. So I'm going to show you a really, really easy way to do iteration. Now keep in mind, the method I'm going to show you is using MistaCalculator. However, again, just to reiterate what I said in the beginning, just in case you skipped ahead, any topic can appear in any paper. Non-calculator, calculator, it doesn't matter. So you do need to be able to do iteration normally. I have an example question. It's a 4-minute video, super quick. It's a grade 9 iteration question on the channel. It's called like impossible iteration question or something. So to do this, here's what I do. I take P0, I just type it into my calculator, I press the equals button. What that does is it saves 220 as ANS. ANS stands for answer. And what it does is it saves the last answer on your calculator. So now if I type this in, I get 1.15. And instead of PT, I'm going to write ANS, minus 20. Now it says 3 days from now. Well, 1 day from now, it will be 230. 2 days from now, it'll be 241.5. 3 days from now, it'll be 254.725. So I'm going to write that down. This will give me the full 3 marks, by the way. However, this would actually only give me 2 marks. Why? Because I'm looking for a number of rabbits. Can I have 0.725 of a rabbit? Or maybe it lost one of his ears or something. No. So you'd round it to whatever the nearest whole number is. So I'm going to say 255. That would be the 3rd mark. Pretty quick, right? And you can do that with every iteration question that isn't on a non-calculator paper. Just so you're aware, for AQA, there hasn't been a non-calculator iteration question in recent memory. By recent memory, I mean since 2012. But, again, I do have a non-calculator example on my channel. You could do this in a longer way using, like, by hand, but, you know, we're lazy, right? I'm lazy anyway. Part 21 of Algebra. Translate simple situations or procedures into algebraic expressions or formulae. And you should be able to derive an equation or 2 simultaneous equations, then solve them and interpret the solution. So this is a very classic example. In a shop, 2 coffees and 3 cakes cost £9.95. 1 coffee and 4 cakes cost £10.35. Hence, what is the price of a coffee and a cake? So again, I'm translating a situation into algebra, but there can be other situations. It could be, you know, I have X amount of money. I give you £20. I then double what's left. How much do I have? You need to be able to write that in an algebraic equation. Or I have £300 at the end of it. How much did I start with? Right? So, the way I'll do this is I'll assign a letter to coffees and cakes. Annoyingly, they're both the same, like, they start with the same letter. So I'm going to call coffees C and cakes, I'm going to call them K. Right? K for cake. Sure. So this first line here says 2C plus 3K equals £9.95. The second one says 1C plus 4K equals £10.35. Now you might notice that the number in front of the letters isn't the same. Okay? So, see what I mean? See, I thought this through. But anyways, What I'm going to do though is I can make them the same by timesing the second equation by 2. Because that will make the C number the same. So I'm going to rewrite the whole thing again, but I'm still going to keep it in the same order, because I think it can be a bit confusing when you, like, if I just wrote the times 2 right after that. So I'm writing the top one the same. Now I'm doubling the second one. And remember, whatever you do to one side, you do to the other. So I'm doubling everything. So that would be 20.7. Yeah? And now the sign in front are both positive. So I'm subtracting. Remember, same sign subtract, different sign add. Same sign subtract is like a, alliteration, right? 2c minus 2c is 0. 3k minus 8k would be negative 5k. And I'm going to use a calculator just in the interest of time, and because I'm, I'm just a lazy guy. 9.95 subtract 20.7 gives me negative £10.75. I really didn't need a calculator for that. Divide both sides by, well, first of all, I can cross out the negatives because they're on both sides. Divide both sides by 5 would give me an answer of 2.15. So a cake costs £2.15. Now, how do I work out the price of a coffee? Well, I can sub it into this second equation. So I have 3 equations, right? 1, 2, and 3. So I'm going to sub it into this second one because it has 1c already. So 1c plus 4 times 2.15 equals £10.35. So 1c plus £8.60 equals £10.35. So subtract it from both sides, and c is equal to, again, I'm not necessarily going to show you how to add and subtract properly. We're just going to use a calculator to get through this as quickly as humanly possible. 7 over 4, which is 1.75. Kind of expensive for a coffee. Anyways. Now we're on to inequalities. So we did mention them a bit earlier, as in the actual definition. It's just when you don't have an equal sign. And we need to solve it in one variable, represent solutions on number lines. And if you're higher tier, solve them as quadratics, and also represent solutions on a number line using set notation and on a graph. So on the number line, show the inequality x is greater than minus 3. So if it just says it's greater than, not equal to, then you put a hollow circle. And since it's greater than, it means it's going to be pointing to the right, and you do an arrow. You have to put the arrow, because remember, it's all values bigger than minus 3, which goes on to infinity. So unless you want to draw an infinitely long number line, you need to put an arrow, okay? So here it says 1 is greater than equal to y. Well, sorry, it's less than equal to y, which is less than 5. Write down all the possible values. Well, it can equal 1, so it's going to be 1. And it goes all the way up to, but not including 5. And it says y is an integer, so we're not going to do the decimals, which is thankful, because that would also go on forever, literally. And then lastly, it says solve this. So minus 7 from both sides. So sometimes I'll come across students, in fact, a lot of the time I'll come across students, that when they see this, they panic because the symbol's different. Here's what I do. I make it an equal sign. Just ignore it, right? It doesn't actually change anything, really. So you can just ignore this and just make it an equals. You're doing the same thing. Subtract 7 from both sides, then divide by 4, which gives you t is less than equal to 3. Okay? So you don't need to worry about if it's a less than, greater than, or anything until the very end. The exception to that is if you divide or times by a negative number, then you have to change the direction of the inequality. But that's it. So again, in your head, you can kind of ignore it for now. What if it's a quadratic? That's a brilliant question. Thanks for asking. What you do here is you, again, factorize. So I want two numbers at times to 3 and add to 4. So that's x plus 3, x plus 1 is greater than 0. Now, that's not satisfactory, okay? And I can't just say x is equal to minus 3, x is equal to minus 1, because it's an inequality. So here's what you do. This is what you don't do. Or actually it would be the other way around, okay? Right? Or anything like that. You don't do this. It's naughty, okay? If someone's taught you that, kill them. Okay. It could be right. Yeah, I'm not going to lie to you. You get that right maybe 50% of the time. But there is another option. It doesn't have to be like this. And I'm going to show you. What you have to do to actually make sure that you got it right is you sketch the graph. Now, don't be too scared. -3 and -1 are here and here. It's a sketch, right? Now, you've seen my drawings. If you had to be a good artist to do maths, then I would be screwed. And because it's a positive x squared, I know it's going to be a big happy face. Okay, anyways. Now, what is it asking me for? It's asking me for the values bigger than 0, which is the values above the x-axis. So that's all of these values here and these values here, right? That happens when we are less than -3, right? Because everything to the left of -3 would be less than it, and greater than -1. That's my answer. It's everything less than -3 and bigger than -1. Okay? Do not ever just assume this. Just quickly sketch the graph and check. Here's a little hint. Okay? I'm going to give you a cheat code because I'm quite fond of you. If it's a positive x squared and it's greater than, it will look like this. If it's a positive x squared and it's less than, it will look like this. If it's a negative x squared, it's the opposite. Okay? Now, if that doesn't make sense, then just do the sketching method. The sketching method is way better. It's the way I do it because I don't like remembering stuff. Remembering stuff makes my brain hurt. Okay? So just learn it. Okay. On the grid, shade the region that satisfies all the equations. All the inequalities. X is bigger than 3, bigger than -2. Okay. Here's what I do. I draw the lines. They look like this. Like that. I'm going to draw these. Now, technically, I'm going to draw the... If they're not equal to... So in this case, none of these are equal to except this one. I draw them with a dotted line. So if it's this or this, you do a dotted line. If it's this or this, it's a solid line, okay? So x equals 3. If I look where x equals 3 is, 3 is here. X equals 3 is going to be a big old dotted line going down like this. Y is bigger than -2. Okay, well, look where -2 is. It's here. And again, it's a dotted line. Now, what about 2x minus 1? Well, the y-intercept is -1. It's here, right? And it's going up by 2 each time. So it's going to be a straight line. And again, I would ask your forgiveness for what... Okay, give up. Yeah, so 1 down 2. So every time we're going 1 across, we're going down or up 2, depending on how you look at it. It's going to be a straight line. And if you notice, it's a solid line. Why? Because it's equal to. So, now if I look at my inequalities again, it's bigger than y is -2. So also, actually, I would recommend labeling these. You want your examiner to do as little thinking as possible. Okay. So it needs to be bigger than y is -2. So it needs to be above this line. X is less than 3, so it needs to be to the left of this line, and it needs to be underneath this line. So in other words, it's this triangular region in the middle. Does that make sense? Hope so. Okay. And then next. Okay, so for sequences, again, another kind of interesting topic in my opinion. Well, my opinion is probably not the same as yours, but anyways, here are the first 5 terms of a sequence. You just need to be able to generate terms of sequence from either a term-to-term or position-to-term rule. So basically, they may give you that the rule is like 4n plus 3, or they may say that it's just, add 3 each time. Right? Because they like to do various different things like that. So we need to write down the next 2 terms in the sequence. Well, if I look, what I would do here is I would see what the rule is. So it's +2, then +3, then +4, then +5. So logically, I'd add 6 to the next one, which would be 22. Then I'd add 7 to the one after that, which is 29. Nice and easy. Now here are all the different types of sequences you get to remember. Yay! And yeah, the only one for higher is when you have essentially a geometric sequence here, but it's a surd. That's literally all that's kind of limited to you. So have fun, foundation guys. You have to do all of these, and higher guys, you also have to do all of these. So here are all the different types of sequences that you need. First of all, we have triangular one. This is one that a lot of people neglect because it doesn't really come up that much, and a lot of students will be like, triangular, what the hell's that? Basically, the difference increases by 1 each time. So just like in this question here, you could call that a triangular well, okay, it's not technically triangular. Not technically anyways. But the idea is that from triangular a sequence, it starts at 1 and then the difference increases by 1 each time. So it goes up by 2, then by 3, then by 4, then by 5, then by 6, then by 7, then blah, 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 blah. Square numbers, so all of your square numbers, we've gone through these before. Cube, again, very similar. An arithmetic sequence adds the same number each time. So for example, 1, 3, 5, 7, I'm just adding 2 each time. The Fibonacci sequence, all it does is it adds the previous 2 terms together to get the next. Now, it doesn't have to start at 1, it can start any number. They might give you like, 5, 5, then 10, and 15, and so on. But they'll keep it relatively low because otherwise the numbers get quite big pretty quickly. And geometric is where you multiply by the same number each time, and if you're higher, the difference could be a surd. So it might be multiplying by square root 2 each time. How do you work out what it's being multiplied by? All you do is you take one term and you divide it by the one before it. So in this case, I'll do 4 divided by 2. And if you notice, if I do 8 divided by 4 or 16 divided by 8, they all give me the answer of 2. So there you go, I gave you a bit of a hint for the surds. I love this so much. Deduce expressions to calculate the nth term of linear sequences. So I'm going to show you a little trick because I think this is fairly useful. This equation is technically A-level, but before you panic, just know that it's a very simple equation and it will always give you the right answer. So, first of all, you work out the difference. So 7, 7, 7, cool. That difference is called D. The first term is called A. So, the general expression for the nth term of an arithmetic sequence is A plus n minus 1 D. You sub in your values for A and D. In this case, 4 plus n minus 1 times 7. Now, technically, you can leave it like that, but sometimes, you know how things are with kind of mark schemes and stuff. So I'd expand it so you get 4 plus 7n minus 7, which means your final answer is 7n minus 3, which if you look will give you the right answer each time. So I would recommend just using that. But yeah, it is technically it's a question that an equation they only really give you an A level. So if your teacher showed you it, you have a very nice teacher. But I think this is so much easier. A is the first term, D is the difference. Just sub it in and it's done. I have foundation students and higher students that both appreciate this, and it takes away the guesswork. The thing I used to hate about sequences, even when I started kind of teaching it, is the guesswork that's involved in some of them. It's very tricky. And sometimes it's not even to do with mathematical skill. You can get lucky and guess the right answer. So this takes away the guesswork entirely from arithmetic sequences. Now with quadratic, there are methods online that you can use which might be quicker than what I'm about to show you, but in my opinion, they don't make sense. You just kind of have to know tricks. I'm going to show you a way that does make sense. Okay? So, if you have a quadratic sequence, it's going to look like this, right? an squared plus bn plus c. Because that's in a quadratic equation, right? A generic one. So here's what you do. First of all, let's do the difference of these things here. That's 6. That's 8. That's 10. That's 12. Yeah? There's no common difference, so you do the difference of the difference. Yeah? This 2 is double what A is. So A is just equal to half of the common difference. Always. Okay? So now what we have is we have n squared plus bn plus c. And I just need to work out what B and C are. I use simultaneous equations for this. Okay, so when n equals 1, right, that would be 1 squared plus b times 1, so b plus c equals 5. Right, so I have b plus c is equal to 4 because 1 squared is 1. Then when n equals 2, I have 2 squared plus 2b plus c equals 11. Right? So that gives me 2b plus c equals 7. So if I call this equation 1 and this equation 2, I can subtract these two equations, right? And again, it doesn't matter which way round you do it. I'm just going to do it in order. So b minus 2b is minus b, c minus c is nothing, 4 minus 7 is negative 3. So b is equal to 3, which means if I sub that into equation 1, I get 3 plus c equals 4, so c is equal to 1. So my actual equation now is n squared plus 3n plus 1. Okay? That's the way I do it, and I find it to be reasonably quick for a 4-mark question. There are some methods online which, again, if you go on Maths Genie, they have a method where they kind of use like a weird table type thing. There are also methods where you just, every time you make a guess, you write out what the new equation is and you find the difference between them and then you half it, blah, blah, blah. So for example, when I figured out this n squared plus bn plus c, I could write out what the equation would be with that equation and then see what the difference. Again, I personally think that there's too much guesswork. So in my opinion, this is just a better way to do it. It's more, in my opinion, mathematical in that sense. But that brings us to the end of algebra. Good lord, that was a long section. On the bright side, the rest of we're over halfway done with the spec. Cool. For example, we have 4 more topics left. Sorry, 5, right? Because we've only done numbers and algebra, but a few of them are really short. So, ratio, proportion, and rates of change. Change freely between related standard units, so time, length, area, volume, capacity, mass, and compound units. Cool. So, with this, a kilogram is 1,000 grams, kilometers, 1,000 meters, meters, and so on. These should be fairly easy by now, these 5, but a mistake I see higher and foundation students make is converting between areas and volumes. Remember, 1 meter squared is not 100 centimeters squared. It's 100 squared centimeters squared. Now, the reason for this is if I draw out my thing, and here I have a meter and a meter, when I times that together, I get 1 meter squared. When I change this into centimeters, though, and I times it together, I get 100 times 100, or 100 squared centimeters. So I get 10,000 centimeters squared. If you just times it by 100, you've only changed one length into centimeters. So you technically have centimeter meters, which is a really ugly unit. You need to square it if it's area and cube it if it's volume for this reason. The last thing you need to do is use compound units and be able to convert them. So changing kilometers per hour into meters per second. So the way you do this is, since kilometers on top, I'm going to kilometers to meters, I'm timesing by 1,000. Now because hours on the bottom, I'm going to be dividing. Right? Now an hour into seconds, well, hours to minutes is 60, and minutes to seconds is another 60. So it would be 3,000 over 3,600 meters per second. And again, you can just work out what that is. It's 30 over 36, so what was it? 15 over 18, 5 over 6, right? Meters per second. So use scale, factor scale diagrams and maps. So generally speaking, this is what a scale would look like. So a model car's length of 8 centimeters and the scale is 1 to 50. This here is the scale length, if you like, and this is the real length. So if you're going from here's how I always do ratios, by the way. To get from here to here, I times by 8. So I'm doing the same thing on the other side, which would give me 400 centimeters. So basically, it's 4 meters long. Okay? Express one quantity as a fraction of another, where the fraction is less than 1 or greater than 1. So here we've got Lily's age is 2 years and 4 months. Hugo's age is 1 year and 8 months. give Lily's age in months as a fraction of Hugo's age. So Hugo is, so 1 year is 12 months, 12 at 8 months would be 20 months. 2 years and 4 months, so 2 years is 24 months, plus 4 is 28 months. So expressing Lily's age as a fraction of Hugo's, whoever comes first goes on top, and whoever's afterwards goes on the bottom, and then simplify, so 14 over 10, 7 over 5. And it says fraction in its simplest form. That doesn't mean you have to give it as a mixed number. But if you wanted to give it as a mixed number, you're more than welcome to. Cool, nice and quick. Use ratio notation and also reduce it to simplest form. Give your answer in its simplest form. Just read the same thing. So a password has 30 characters, it has 5 numbers and 15 letters and some symbols. Work out the ratio of numbers, letters to symbols. So the first thing we need to do is actually work out how many of each we have. So I'm going to do N, L, S. Numbers we already know is 5. Letters we already know is 15. Now logically, the rest should be symbols because it's only made up of numbers, letters and symbols. So 5 plus 15 is 20. 30 minus 20 would give me 10 symbols. So in its simplest form, it works exactly like fractions. What can I divide all 3 of these numbers by? I can divide them all by 5. So that would be 1 to 3 to 2. Nice and quick. You also need to be able to divide a given quantity into 2 parts in a given part to part or part to whole ratio. God, almost had a stroke reading that. But essentially you need to be able to divide things into ratios. So Will and Ollie share £80 in the ratio of 3 to 2. Here's how I do it. So Will get this as a fraction. So you take the top number. Sorry, the number that refers to Will is the 3, right? So Will get 3 as the numerator because 3 is his number. And then you add the 2 numbers together. 3 plus 2 is 5. So he gets 3/5 of £80, right? So to do this, you do 80 divided by 5 times by 3. 80 divided by 5 is 16 times by 3 would give me £48. Now technically you can just do 80 minus 48 to work out how much Ollie gets, but let's do the same method. Change this to a fraction. Ollie's number is 2, and then over 3 plus 2, which is 5 times 80. Again, 80 divided by 5 is 16 times 2 is £32. We're hammering through this. 5 points in about 5 seconds. Okay. Whoopsie, whoa, that jumped a bit. Well, and it did again. All right. Express a multiplicative relationship between 2 quantities as a ratio or a fraction. So if you look here, by multiplicative relationship, I mean if I say something like, I have twice as much chocolate bars as you. That's a multiplicative relationship because I'm saying twice as much. Or I have 3 times as much money, or whatever. So it says there are twice as many blue counters as yellow counters. So to write this as a ratio, the twice bit means 2, so I put 2 here, and 1's on the other side, because can you see the left side is 2 times bigger than the right side. There are 3 times as many red as yellow counters, so again that'd be 3 to 1. And then it says write down the ratio of blue to red to yellow counters. So here's what you need to do when you combine ratios. Can you see that I have a letter that's in common? Right? Yellow. I need to make sure that their associated numbers are the same. Oh look, they are the same, which means I can just write this all as one big ratio. So blue to red to yellow is just 2 to 3 to 1. If they were different, like let's say this was 2 instead, I'd have to times this first ratio by 2. And again, do it to both sides. Understand and use proportion as equality of ratios. So basically this is proportion. And the way I do proportion is it says here 6 cakes cost £10.74. So I can do 6 to 10.74. And I want to work out how much 11 cakes is worth. So I work out how much I times 6 by to get to 11. And how do I work that out? Well, simple. You just divide the 2 numbers. And you do that to the other side as well. This was, by the way, a calculator question. So, you know, good old lazy boy Mitch can just use his calculator. Whoa, that was careful. Times 11 over 6, which is £19.69. Yeah. So yeah, proportion is equality of ratios, right? If you keep things in the same proportion, they'll always have the same ratio, right? So again, if I go back to the example of like me having twice as much money as you, M to Y, then even if I earn, let's say, £10,000, that means you must have, well, £5,000, right? The ratios are equal though. I can simplify that back down to 2 to 1 easily. So I just work out how much I times 2 by to get to 5,000, do the same to the other side. Relate ratios to fractions and to linear functions. So I've actually already done this with you. Red to blue is 3 to 5. Which fraction are red? So red, the number for red is 3, and you divide it by both sides added together. What happens if it's like a three-way ratio? So say if it's 3 to 5 to 2, then it would still be 3 over, but then you add all three numbers together. So in this case it's 3 over 8, which is that one. So let's get started with percentages. So here it says define percentage as a number of parts per 100. Essentially a percentage is just a fraction out of 100. So if I gave you 30%, for example, all it means is 30 out of 100. Same thing, okay? So we need to be able to convert between decimals and fractions and percentages. So if you have a decimal, to convert it to a percentage, super easy. You just multiply by 100, which gives you 29%. To do a fraction as a percentage is a little bit more legwork, but we're going to use this fact that we have up here. We're going to make the denominator equal to 100. So how do I get from 50 to 100? I times by 2. So that's 6 over 100. So it means this must be 6%. Working out percentages of a number. Again, there are so many ways to do this. I've shown before that you can use the percentage button on your calculator. So 10% of 95. You just do 10% times 95. Gives you 9.5. But to take 10% of a number, you just divide it by 10. Okay. Next thing we need to do is percentage change. Now there's a reason why percentage profit and percentage loss aren't really used in the spec, because they are both just percentage change. Okay, so the way you do percentage change is you take the new value, so in this case it's 213,590, you subtract the old value and you divide it by the old value multiplied by, and then you multiply it by 100. Okay, so let's get through that. So we have 590 minus 201,500 all over. Ooh, I got that wrong. Interesting. Ooh, I wrote way too much here. What happened here? Two 590,201. There we are. Don't know what happened there. 210,500. Okay, and then multiply it by 100. That is 6%. So that's a 6% profit because it's a 6% change. Now here's what happens when you get a loss, right? Do the same thing. So you do the new value, which is 325,600, minus the old value, 35200, over the old. Now, those of you that are a bit sharp, you might be able to see that it's just going to give me a negative number. That negative number is because it's a loss. That's it. Okay, so all you need to do is, if you get a negative percentage, you just make it positive and say it's a loss. Should be another 0 on that top one. And so yeah, we get 7.5%, negative 7.5%. So if they're asking me what the percentage loss is, it's just 7.5%. And lastly, we need to be able to do kind of a reverse percentages and also compound interest. So work out the normal price of the book. The sale price is £4.80. So it's been reduced by 20%, which means it's currently at 80% of its actual value, right? So to convert that into 100%, you can do a few things. You can divide by 8, then times by 100, or you can again use a calculator. 80% of the total value x is equal to £4.80. So what you can do is do x is equal to 4.8 divided by 80%. It's the same as dividing by 0.8, by the way. So I want to prove that to you right now. So 4.8 divided by 0.8, both the same thing. You get £6. For compound interest, here is the formula. All you're going to do is you take the original amount, 2,500, you times it by the percentage. Now here's the key thing, right? The original amount is always 100%. If I times something by 100%, it stays exactly as it is. So interest is always an increase in value. So a 3% compound interest means you're getting 103% of your money every single year. And then you do that to the power of the number of years. So again, I've done 3% plus 100%, give me 103%. In my opinion, it's easier than the method that schools tend to teach you, which is where you add 3 and then divide it by 100 and do all that. Instead, you can just use the good old-fashioned percentage button on your calculator. And again, we want to do this to 2 decimal places because it's money. 2813.77. Nice and easy. Now, solving problems involving direct and inverse proportion, including graphical and algebraic representations. Direct proportion is a straight line through the origin. Inverse is the reciprocal graph that we had before. Okay? So if they ask you to match up, which they can ask you to match up which graph is direct, which is inverse. Direct has to be a straight line through the origin. So they may give you a straight line that goes like up here or maybe down here. That's not directly proportional. Directly proportional has to be through the origin. Inverse, it doesn't really matter. It has to just be reciprocal graph here and here. To solve these equations, there's a few ways to do it. If A is, I'm going to show you a method where it doesn't, so basically this is a fairly easy one, right? And because it's easy, there is a shortcut way of doing it. The method I show you is going to work no matter how difficult the question is, which means you always get the full marks. So A is directly proportional to B, so that means A is equal to KB. That gives you 1 mark straight away. Okay? And it says when A is 7, B is 28. So 7 is equal to 28k, which means k is equal to 7 over 28, which is a quarter. So my equation is now A is equal to a quarter of B. Now it says find the value of B when A is 5. So 5 is equal to a quarter B times both sides by 4. B is just equal to 20. 3 marks. You get a mark for working out what K is and a mark for the final answer as well. Can you jump straight to the answer and get full 3 marks? Yes, you can. But bear in mind that you have to be 100% sure you're getting it right. Otherwise you get 0. Just writing this gives you a mark. So easy. So you may as well do it. If you want, write this and then jump straight to the answer. At least then you're guaranteed to get 1. Now when it's inversely proportional, instead of K times that, you're going to do C is equal to K divided by it. Okay? So directly proportional means you just have all the letters on the same fraction. If it's inverse, then you're going to put a fraction with the K on top. So when C equals 3, and again we're following the same steps. So K is equal to 24. So that means C is equal to 24 over D. So find the value of C when D is equal to 2. It equals 12. Boom. 3 marks again. Okay. Using compound units such as speed, rates of pay, unit pricing, etc. and using pressure. So I've got all of the main ones that you can be asked for. We have density, we have pressure, and we have speed. These are the main ones they're going to give you. So 200 meters in 25 seconds. Well, speed is just equal to distance over time. So that's 200 over 25, which is 8 meters per second, which is actually incredibly fast. Piece of gold has a mass of 76 grams and a volume of 40. Well, density is just equal to mass over volume. So you have 760 over 40. So cross out the zeros. Half that is 38. Half again is 19. grams per cubic centimetre. And pressure is just equal to force over area. It actually tells you that one. 120 over 2 is 60. You can call it pascals, or you can call it newtons per square metre, or you can call it pascals. And that brings us on to number 12. So moving on to scale factors. So the first type of scale factor is not too bad, but the other scale factor tends to be quite tricky for a lot of students. So you need to be able to compare lengths, areas and volumes using ratios, as in scale factors make links to similarity. So if I scroll down a bit, if you look at these two triangles, they are mathematically similar. What that means is all of the sides have been multiplied by the same number. So for example, to get from 8 to 12, they've times by something. To get from 26 to this blank side, they have something, and so on. Now it says calculate the length of PR, which is this length over here. So to do that, we need to work out the scale factor. So what do I times 8 by to get to 12? To work that out, all I do is I do 12 divided by 8, which I believe is just 1.5. But again, this is a calculator question, so we're more than welcome to do that. But it is 1.5 in this instance. So to work out PR, I take the corresponding side and I also multiply it by 1.5, which should be 39 centimetres. So all I've done is I've done 26 multiplied by 1.5. Now calculating the length BC, I'm not actually going from the smaller shape to the bigger shape. If you have a look, I'm actually going from the bigger to the smaller. So hopefully it logically makes sense that I'm not going to times by 1.5 because that means the side will be bigger. I'm actually going to do the opposite. I'm going to divide by 1.5. So something times 1.5 gave me 45. So working backwards, we can work out that it's going to be 45 divided by 1.5, which is 30. Cool. Now here is when you have things like surface areas and volumes. So the key thing here is if we have this as a ratio, we have 4 to 8, right? So the ratio is for the lengths, right? Because we have radius, which is just a length. So to work out the surface area, right, we need to work out the scale factor of the surface area. So here's all you need to do. A is the smaller shape, B is the bigger one. Okay? If I square this ratio, right, I get 16 to 64. That is the ratio of the surface areas now. Okay? So length squared gives me surface area. Length cubed will give me the ratio of the volumes. Okay? So just as a recap, length, square it, you get the surface area. Cube it, you get the volume ratio. So in this case, the surface area of shape A is 80, so we know that it's gone to 80. We need to work out what it is for this side. Well, to go from 16 to 80, I'm timesing by 80 over 16. So I'm going to times the other side by 80 over 16. And hopefully that makes sense. It basically just depends on how many dimensions you have, right? So what I mean by that is a length is one-dimensional, an area is two-dimensional, so you square it. Volume is three-dimensional, so you cube it. 80. 320 centimeters squared. And then for volume, again, we're doing a very similar thing. So the ratio for the volume would be 4 cubed to 8 cubed. 4 cubed I know is 64. I don't know what 8 cubed is actually. Thank God for calculators. 512. I feel like I should have known that. Anyways, it tells me that the volume of shape B is 600. So what do I times 512 by to get to 600? I times it by 600 over 512. So I do the same thing with the other value. So times it by 600. So we do 64 multiplied by 600 over 512, which is 75 centimeters cubed. Yeah, so that's my answer here. Whoops. So 75 centimeters cubed. Then says that understand that x is inversely proportional to y is equivalent to x being proportional to 1 over y interpret equations that have direct and inverse proportion. And then it also says construct equations that give direct and inverse proportion. So I thought this would be a good time for me to show you this type of question here. Again, this actually comes up with higher and foundation. They sometimes give you this kind of setup and they say, is it y is proportional to x squared, or proportional to x cubed? So what you have to do here is, if I set up my three equations, again, you can do this a lot faster on a calculator. Okay? But if y was proportional to x, then y would equal to kx. If it was proportional to x squared, it'd be kx squared. So again, I just want to point out that this is much faster to just do it on your calculator, but I'm going to explain that to you. Now, to work out which one this is, right, the constant will have to be the same for both sets of values, if it's the right equation. So what I'm going to do is I'm going to do k is equal to y over x for both values. So I have 256 over 4 gives me 64, right? And 500 over 5 gives me 100. So I know for a fact it's not kx. This one, it's y over x squared. Let's check it. Again, we're going to do the same thing. So for the bottom one, squared, it's 20. And then do the same thing, but for the other value, it's 16. So we know it's not this one, which means it must be cubed. Okay? Now, of course, let's prove it. So that gives me 4. So it's both correct, okay? And this says write a formula for that in terms of that. You just do y is equal to kx cubed, sub in the values and work out k like we did before, okay? But that's how you would do it. Interpret the gradient of a straight line graph as a rate of change. So we've already kind of gone through this before. This is the exact same question we had previously. Work out the rate, you're just doing the gradient. So we have done that previously. Recognize and interpret graphs that illustrate direct and inverse proportion. Again, this is something we've done previously. Direct proportion will be a straight line through the origin. Inverse proportion will be kind of this reciprocal graph that you have here. Next, we need to interpret the gradient. So this is only for higher tier. Interpret the gradient at a point on a curve as an instantaneous rate of change. Apply the concepts of average and instantaneous rate of change in numerical context. So here it says the graph shows the height above the ground of a toy rocket for 10 seconds. After 6 seconds, that's here, we need to estimate the gradient. So the way you would do this, and this is going to be very tricky for me to do, is you draw a tangent and then you're just working out the gradient of that tangent, and that will give you the speed. They do give you a fairly decent range, but of course I haven't done this with a ruler, so it won't be correct. And then your units, of course, are meters per second. How do I work that out? Well, the y-axis is meters, x-axis seconds, so it must be meters per second. Set up, solve, and interpret the answers in growth and decay problems, including compound interest, and also work with iteration. So we've actually already done compound interest, but just as a reminder, you take the amount of money, you multiply it by 100% plus 1.8%. Because, remember, with interest, it's increasing. It would really suck if your bank account would take money away from you every year. And then at the end of 5 years, you just put it to the power of 5. Nice and easy. So working out that value. And again, I would recommend just using the percentage button on your calculator. So if no one's ever showed you that before, I'm sorry, but this is probably the better way to do it. The percentage button actually just changes it into a decimal for you. And you get 10,386.34. And obviously that'd be in pounds. What about depreciation though? Well, depreciation is the opposite of interest. Okay, it's when you're decreasing. So if I added the percentage for interest, I subtract the percentage for depreciation. So if it depreciates by 30%, I do 100 minus 30%, which is 70%. Now, I actually picked this question because it also has a changing rate. Now this works for interest and depreciation, which is why it's really, really cool. You take the amount, again, times it by 70%. Easy, right? That's for 1 year only, so I put to the power of 1 year. If the interest or depreciation rate changes, you can just chain on the new percentage. So 100% minus 14 will be 86%. And that's for the second and third year, so that's for 2 years. So you can do that. You can just chain them on, okay? Which is really quite handy. Oops. 15,000 times the percentage sign. It's the power of 1, but I'm not going to bother putting the power of 1. $9318.96. Cool. And with iteration, we've done this before. Again, all you're going to do is take the original number, press equals, then sub it into your formula. And in this case, I'm clicking it 3 times. So 1 year, 2 year, 3 year. Round to the nearest whole number, 57,553. Nice and easy. I think we just kind of speed ran all of ratios, which is quite nice. And now we're on geometry and units of measurement. So we're beginning geometry. So with geometry, you have to be able to use terms such as points, lines, and vertices. So a point is just, a point, a line is a line, and a vertice is a corner, essentially. Edges are the sides of a shape. Planes, essentially is just a flat 2D object. Parallel lines, so 2 lines that never meet. Perpendicular lines, 2 lines that cross at right angles. Right angles, angles of 90 degrees. A polygon is just a many-sided shape, so anywhere between 3 and infinity. Regular polygons means that all of the sides are the same length and all the angles are the same size. And polygons with reflection or rotation symmetries. You'd also need to use the standard conventions for labeling and refer to the sides and angles of triangles, so things like the hypotenuse as an example. So, next part, we need to be able to use a standard ruler and compass construction in order to construct accurate drawings of diagrams and also to kind of do loci. So how do you do these? Well, the next thing also is know that the perpendicular distance is the shortest distance possible. So how do you do these? Well, I would recommend looking up some videos on these, but the way you do it is if you had to draw this exact shape, I'll draw the flat side 10 centimeters, okay? Then for your 6 centimeter length, you're going to get your compass and move it out to 6 centimeters wide and draw an arc going around like this. Then you move it to point B and make it 8 centimeters wide, draw a big arc. Where those 2 arcs cross is where you're going to draw the line in order to connect them. For this question here, it must be no more than 10 kilometers from town A and no more than 8 from town B. 1 centimeter represents 2 kilometers, so you're going to do a 5 centimeter and a 4 centimeter circle around each of these points. So you move your compass out to 5 centimeters, draw a full circle, do the same thing for town B. Where they overlap is where you're going to shade. Okay, now for the different types of angles that we have. So this here is a vertically opposite angle, and so is these two. So when you make a X shape with 2 lines, the opposites angles are always equal to each other. This one over here is an alternate angle, so what that states is that you have a Z shape, and again remember all 3 of these situations here, here and here are with parallel lines, okay? So parallel lines, you draw a line between them. What are the angles? So here you have a Z shape. You can also do it as like a reverse Z shape, so these 2 angles are also equal to each other. And all you'd say is alternate angles are equal for the reason. Here you have corresponding angles, so you have like this F shape, and the angles underneath the lines are all equal. And again, you can do it on the reverse side as well, of course. And lastly, you have co-interior angles, where the angles on the inside should add up to 180 degrees. Lastly, you have these 2 formulae, which are really useful and you should remember. The sum of the interior angles in an n-sided shape is just n minus 2 times 180. So for example, the triangle has 3 sides. 3 minus 2 is 1 times 180 is 180. It works for every single shape with multiple sides. And exterior angles, again, you're doing 360 divided by the number of sides you have. Okay, next one. Derive and apply the properties and definitions of special types of quadrilaterals. So square, what's the special properties? Well, all angles are 90 degrees. And all sides are the same length. With rectangles, the opposite sides are the same length and parallel. And yeah, so the opposite pairs of sides. And again, all angles 90 degrees. This here, the opposite pairs of sides are parallel. However, this is key, the angles are not 90 degrees. So the only difference between a rectangle and a parallelogram is that the angles in a parallelogram are not 90 degrees. Okay? Because if one of them's 90 degrees, then the other one has to be 90 degrees and so on. Okay? So a rectangle is a special type of parallelogram. So, what other things are kind of unique is that these angles are co-interior. So if I call this A and B, A plus B equals 180 degrees. Now, the other interesting thing is that the opposite angles are equal to each other. Okay? So, the co-interior angles, the ones that are adjacent to each other, will add up to 180 degrees, and the angles directly opposite will all be the same. Okay? Trapezium. What's important about a trapezium? The top side and the bottom side, or two pairs of sides, are going to be parallel to each other. The other two are not going to be parallel to each other. And again, we have that these angles here are co-interior. So if we call them A, B, C, and D, A plus B equals 180, and C plus D equals 180. But the opposite angles do not have to be the same. Okay? Over here we have a kite shape. The key important thing here is that it is symmetrical about this line down the middle, which means these sides are both the same length and these sides are both the same length. And the reason why that's important is that the opposite angles are also equal to each other. Then lastly we have a rhombus. And the key thing about a rhombus is that all of the sides are parallel, as in the pairs of sides are parallel, and they're also the same length with each other. So effectively, it's a parallelogram that's been flipped on its side. Okay? Now we have the congruence criteria for triangles. So when something's congruent, it means it's identical. The only thing that might be different is its orientation. So they might flip it upside down or something. So, what do these criteria mean? Well, SSS means that if all three sides, so it means side, 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 if all three sides are the same length, then both triangles or both shapes, well, no, triangles, are the same. They're identical. They're congruent. This one here is a bit more tricky. Let's say we have a triangle like this, and you know that this side and this side are the same, and the angle between them are the same, then they are identical triangles. They're congruent. So keep in mind with SAS, it has to be the side, the two sides, and the angle between those two sides. So if you had something like this, side, side, and angle, that doesn't mean it's congruent. It has to be the ones between. ASA, again in the same vein, if I have a triangle and I have the side and both angles which are touching the side that are the same, then they are congruent. And lastly, RHS means if you have a right angled triangle and the hypotenuse and one other side is the same, then you have congruent triangles. Again, I have done a bunch of these questions in our live lessons. So here it says ABCD is a parallelogram. Prove that ABC is congruent to BCD. So what they're doing here is they're cutting this in half. Now I would like to point out that if you're proving two triangles are congruent, it actually means you can use all three of these at the same time. So in a mark scheme it might say SSS, but you could use SAS or ASA as well. So how can we prove this? Well, first of all, CB is shared, which means both of them have one side that's the same. Now, because it's a parallelogram, CD is equal to AB, because opposite sides of a parallelogram, and AC is equal to BD, which means it's SSS congruency. However, you may also notice that these angles will be the same. So you also have two sides that are the same and two angles that are the same. Therefore, it could also be SAS, because you have two sides and the angle between the sides. And again, you would find that it's also ASA, because these opposite angles will be the same and they've been cut in half. So, again, applying all of these in order to do simple proofs, just like we did above, showing things are congruent. You also need to be able to identify, describe, and construct congruent and similar shapes on coordinate axes by considering rotation, reflection, translation, and enlargement, including fractional scale factors, and then with higher tier you have to do negative scale factors. So I'm going to show you how to do scale factors. So first of all, you look where your center is. 1, 0 is here. Now we're enlarging by a scale factor of 2, so here's how we do it. I'm going to start by looking at this first point. To get to that point, I go 1 to the right and 2 up. So after I've enlarged it, I double. So 1 to the right, 2 up becomes 2 to the right, 4 up. So 1, 2, 1, 2, 3, 4. That's my new point here. Okay? And I do that with every single point. To get there, I need to go 1, 2, 3, 4 to the right and 2 up. So that becomes 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8 to the right. So it'll be on 9. And then 4 up. 1, 2, 3, 4. This one is 1 to the right and... yeah, that's correct. 1 to the right and 2 up. So now it becomes 2 to the right and 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. And then all you do is you join all the points with a nice straight line, in theory anyway. Again, you'd use a ruler. But as you can see, those shapes are identical, they've just been enlarged. Now if you're higher tier, you have to do negative scale factors. So I've got the exact same question, except I made it a scale factor of -2. So again, center is 0, 1. So that's here. Now what do? Same process. So I go 2 to the right and 1 up to get to this point here. And the scale factor is -2. So here's what you do. You times it by 2, not -2. So 4 and 2. But you go in the opposite direction. So instead of right, you go left. Instead of up, you go down. So I'm going to go 1, 2, 3, 4 to the left, 1, 2, for 2 down. Okay? And I do this with every other one. So this one is 1, 2, 3, 4 to the right, 1 up. So I'm going to go 8 to the left, 2 down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. This one in the middle is 1, 2, 3, 4 to the right. And it's 1, 2, 3, 4 up. So we're going to go 8 left, 8 down. So 1, 2, 3, 4, 5, 6, 7, 8. And hold on. Sorry, it should be 6. I misread that. That's 3 actually. So 3 and 6. I did do the other one, right? 1, 2, 3. Yeah, I did. Okay, so it should go to -6 and 1, 1, 2, 3, 4, 5, 6, 7, 8. So the way I realised that was going to be wrong is obviously it was going to be in line here, which would make it a right angle triangle. So again, the shape should be, it should look the same. It's just kind of inverted and bigger. Okay, so that's what you'd need to do for scale factors. And next we have, okay, and for higher tier people, you have to be able to describe changes and invariances caused by combinations of rotations, reflections, and translations. So you're just going to be doing the standard transformations and saying whether the points will change and what they'll change to. So essentially it's the same. The method will be the same as just sketching these transformations themselves. Okay, for part 9, we have to identify and apply circle definitions and properties, and we need to identify where the center, radius, chord, diameter, circumference, tangent, arc, sector, and segments are. That's a hell of a lot of stuff. So let's start. The center of a circle is shockingly right in the middle. The diameter is the width of the circle, okay? And essentially, it is a chord that goes through the center of the circle, okay? And what is a chord? A chord is just a line that goes from one point on the circumference to another point on the circumference. So a diameter is actually a special type of chord. Okay, so a chord is just a line that goes from one side of a circle to another. So again, between any 2 points on the circumference, anything along here. And the diameter is a chord that goes through the center of the circle. It's just the width of the circle. The radius is exactly half the diameter. It is the distance from the center of a circle to its circumference. So we've done the first 4 already. The circumference is just a fancy word for the perimeter of a circle, and again we just call that circumference. Okay, but they both mean the exact same thing. Now for a tangent, that is going to be a line that touches the circle at exactly 1 point. Okay, so if you look here, it only touches at 1 point here. For the last couple, arc, sector and segment, I've done a fantastic drawing here. An arc is just a fraction of the perimeter of a circle. So it's a fraction of the circumference. So when you have a sector, the arc is just the curved part of the perimeter. A sector is basically a pizza slice, okay? So this whole thing here is a sector. And lastly, a segment is what you get when you draw a line joining 2 points of the sector, and it's the leftover kind of curved piece. I like to call it like a little orange slice. So it's just basically a chord and that area that's cut off from it. For part 10, you need to apply and prove the standard circle theorems concerning angles, radii, tangents, and chords. So first of all, here's all of the kind of circle theorems you need. So again, shout out to Third Space Learning. But you have the alternate segment theorem, so you can pause and look through these at your leisure. But for this question, B is a point on the circumference of a circle, AB is a tangent to the circle, BOA is 72 degrees. Work out the size of the angle BAO, which is this angle here. And it says you must show what you're working out. So first things first, you're going to use the circle theorem that the tangent of a circle meets the radius at 90 degrees, always. So over here. So this is a right angle, which means this is a right angle triangle. So we just do 180 minus 90 minus 72 to work out what that angle is. So that's 90 minus 72, which is 18 degrees. And for this one, points on the circumference of a circle, BOC is 66 degrees. Work out the size of angle BAC. We're just going to use the fact that angles at the center are twice that of the circumference, which means this will be half the angle at the center, which is 33 degrees. Nice and easy. So the reason again is because angles at the center are half that at the circumference. Twice that at the circumference. Solve geometrical problems on a coordinate axis. So something like this. So write down what the coordinates are for point C. That would be 1 minus 2. Again, we've gone through this before. Find the coordinates of the midpoint of AB. So you can kind of do this by eye. So if you look at the width, it's 4. So it should be over here and then halfway up. So the midpoint would be exactly here. And lastly, mark where it would be for it to be a square. So if you look at all of the sides, they go 4 down and 1 across. So if we do the same thing here, we can go 1, 2, 3, 4, 1 across. It should be over here to make that a shape. A square, sorry, not a shape. Identify properties of the faces, surfaces, edges, and vertices of cubes, cuboids, prisms, cylinders, pyramids, cones, and spheres. So you may be asked to work out things like the total surface area. So you should know that the surface area is basically just the area of all the faces added together. With a cuboid, these faces here, here, and then one on the back and one on the bottom are actually all the same. So you have 4 faces that are just this kind of rectangle. So you're going to do 4 times 12 for the width and the height is 4. Like that. And then you're going to add on the 2 faces on the side, which is 2 times and then 5 times 4. Okay, so you should know. So again, this is part of the kind of properties, is that for a cuboid, you have 4 of the same face and 2 of a different face. So you only have 2 different areas to work out. Likewise here with the triangular prism, find the total surface area. This first set is a rectangle. The one on the back is a different rectangle. The one on the bottom is also a different rectangle, but you have two of the same triangle. And it should, in theory, make your life a bit easier. For 13, you should be able to interpret plans and elevations of 3D shapes, construct and interpret plans and elevations of 3D shapes. So to draw this, remember a plan is a top-down view. So what this is telling me is that from the top down, it's 3 wide, but if you look at this line along here, so it's 3 wide, but if you look at this line along here, it means that there's actually a break. And if you look at the front elevation, this is literally a view from the front, it looks like this. So you can see that part of it is going to bump up, which is where this comes from, and a side elevation shows you the look from the side. So if I were to read this, my front looks like this, so I'm going to draw this out. Again, keep in mind, you don't have to be like Michelangelo or anything. And I know that since this is a centimetre grid, this height is 1, this width is 2. So I'm going to say this is 2 centimetres, that's 1 centimetre, that's 1 centimetre, and that would be 3 centimetres at the bottom. Height is 1 centimetre, and that is 2 centimetres, right? And then all you'd have to do is make this 3D. So I'm actually going to get rid of the measurements for now, just to make my life a bit easier, but I wanted to show you how to interpret it. So the way I would make this 3D is I'll do something like this. So it's like a staircase, right? A very wonky staircase. But that is what it should look like. This depth here and here should be 2 centimetres, because as you can see, there's 2 centimetres before it goes up. So that means all these widths are 1. The actual width of the shape, this length, should be 3, and the overall height should also be 2, and this should be 3. Okay, so it's just like a staircase. And hopefully that makes sense how I kind of got to that. You need to be able to use standard units of measure and related concepts like length, area, volume, capacity. So we have gone through these earlier. So the units for length, things like meters, centimetres, millimetres, and kilometres. Area should be millimetre squared, centimetre squared, metre squared. Volume or capacity should be millilitres and centimetres cubed. Mass, kilograms and grams. Time, hours, minutes, seconds, days, years, all of those can come up. Money, pounds, okay, and pennies. You should also be able to measure line segments and angles correctly, so you need to be able to use a ruler and a protractor accurately, and in turn calculate things using those measurements. You should be able to calculate the area of all of these different shapes that we have here and volumes of these kinds of shapes. So area of a triangle. Okay, now keep in mind that if you're higher tier, there is another area of a triangle that you need to know, which is for a generic triangle, which is half AB sine C. But for just right angle triangles, it's going to be half, and also for like isosceles and things like that, half, in this case, B times A. Parallelogram, you use the base and you times it by the vertical height, not the slanted, the vertical, and that's just going to be B times H. For a trapezium, again, you need the vertical height, not a slanted length. And then you have the two parallel sides. It's going to be a few different ways you can write it. This is my preferred method. But some people write B plus A over 2H, which is also technically correct because they're the same thing. Volume of a cuboid is just going to be the area of one of the faces. Basically, you're just timesing all the lengths together, right? So I think we call this width, call this height, and you can call this depth or length, whatever you want to do it, and you're just timesing all of the sides together. But in general, for a prism, all you do is you work out the area of a face and you times it by the length. So I could work out the area of this front face and times it by the depth. So W times H times D, again, that's the same thing. If it's a triangle, half base times height times the length, anything like that. And with the cylinder, it's the same concept. You have a height and you should have a radius. So how do you work out the area of this circle at the top? Well, the way you do that is you do pi r squared, right? Cool. That's the area of this. Then you times it by the length of the prism, which is in this case just the height. So it's pi r squared h. And again, that would work for any shape on top. Square, rectangle, whatever. You should also know the kind of formulae for this for a circle. Looks like I've done the so these pictures are meant to be for the above ones. So knowing these different types of circumferences and work out the perimeter of 2D shapes, including circles, areas of composite shapes, things like that. So I've picked an area of a composite shape for this one. So if you look, it is a trapezium, so you can use the area of a trapezium if you want. But if you look, it's just a triangle and a rectangle, and it says work out the area. So you'd work out the area of this shape, and plus it's the area of this shape. So that is, for the one on the left, it would be 5 times 7 plus half times base, which is 4, times height, which is 5, because remember this length will be the same as this one over here. And that will give you your answer. So 5 times 7 is 35, that would be plus 10, so it should be 45. And if you use the trapezium formula, a half a plus b, so in this case it would be 7 plus both of these added together, so 7 plus 11 times h, you'll actually get the exact same answer, which is, I mean, I find it interesting, 9 times 5, which will give you 45. And again, you do the same thing here. You can break it into 2 separate values, where this would be 4 centimeters, and this would be 5 centimeters, and then you have a trapezium and a rectangle added together. You should be able to calculate arc lengths and angles and areas of sectors and circles. So if you noticed, the way I explained it is that a sector is just a fraction of a circle, correct? So this area then should be a fraction of the area of a circle. So it's going to be pi r squared, but we need to take a fraction. And how do we work out that fraction? Well, it's not a semicircle, so I can't divide it by 2. It's not a quarter circle, so I can't divide it by 4. So what can I do? Well, the way we get that fraction is we take the angle that's here, right? And we divide it by the total angle in a circle. So we do 150 in this case. And what's the area, angle in the circle? It's 360. That will give us our final answer. So if I do this on a calculator, because again it says 3 significant figures, which means we do have to do pi. 150, over 360 multiplied by pi, which is shift, and the times 10 button, times radius, which in this case is 8 squared, gives us our value. So 83.8 centimeters squared. What about the length of an arc? Well, it's the same thing. Remember, when you have an arc length, that is a fraction of the circumference. And if you remember, the circumference is either 2 pi r or pi d if you prefer. And again, we're going to just take the angle and divide it by 360. In this case, r is 18. Nice and easy, hopefully. We've done this as well. Apply the concepts of congruence and similarity, including relationships, and also find the relationships between lengths and areas and volumes in similar figures. So we have done that previously. That should all be fine, but again we may have some extra ones. So know the formulae for Pythagoras' theorem and all the trig stuff, and use them to find angles and lengths. And here it says apply them to find angles and lengths in right angle triangles where possible, general 2 triangles in 2 and 3 dimensional. So that sounds very complicated. Basically, for right angle triangles, that's foundation tier. In higher tier, they might introduce a 3-dimensional aspect to it. Okay? And by that I mean they might have like a 3D shape and then work out an angle, and it's just a bit difficult to visualize. Other than that, it should be completely fine. So for this, so when do you use Pythagoras versus trigonometry? Well, both of them, it has to be right angle. It has to be. Now, you only use trig if you want to find an angle or you're given an angle, right? So in this case, if you look at the first one, I have 2 sides. I don't have an angle and I want a length. So I don't have an angle and I don't want an angle, so it's Pythagoras. And again, you just label this as C, because with Pythagoras, the only letter that matters is what C is. The rest of them, it doesn't matter which way round you do it, because you're just squaring and adding them. So you have 4.8 squared plus 3.6 squared, C squared. So type that in on a calculator. It's 36. Well, that's a nice number. So don't forget, that's not what C is. C is the square root of 36, which hopefully you know is 6 centimeters. The next one, work out the value of x. Well, I have a side and I want a side, so it's Pythagoras, right? No, because we get given an angle. So here's how you do trigonometry. Again, I'm not going into super detail about this. This is just like a quick recap. The opposite side to the right angle is always h, it's hypotenuse. The opposite side to the angle you're given, or the one that you want, is always opposite, and the one that's next to the angle, the other one that's left, is just the adjacent. So I'm going to write out toa. Yeah. Now I want side h and I have side o, so I have o and h, which means I'm going to be using so. And so just says that sine of the angle, so sine 35 is equal to the opposite side 20 over the hypotenuse, which is x. So if I rearrange this, so times both sides by x, then divide both sides by sine 35, I get x is equal to 20 over sine 35. So all I need to do now is enter in a calculator. Okay, which is 34.9, let's call it. Okay. And for the next part, we need to know the exact values for sine, cos, and even some for tan as well. So how on earth do we do this? Well, it's actually not that bad. There is a little trick that you may have already seen, but I always do it in like a little table. So we do sine, theta, and then write down the values on top. So 0 degrees, we need 30 degrees, 45, 60 and 90. Now here are the values that you need. You need to do, it's 0, half, root 2 over 2 or 1 over root 2, depending on which way around you look at it. Root 2 over 2, and then the next one is root 3 over 2, and the last one is 1. Now how do I get those? Well, all you're doing is actually adding 1 each time. What do I mean? Well, here's what you do. You put over 2 for all of them. Okay? So all of those over 2. And then I start at 0, square root 0, square root 1, square root 2, square root 3, square root 4. Square root of 0 is just equal to 0, so we've got 0 divided by 2, which is 0. Square root 1 over 2, well, what's the square root of 1? It's 1, so 1 over 2. Square root 2 over 2 is just square root 2 over 2. Square root 3 over 2 is just square root 3 over 2. And square root 4 is 2, so 2 over 2 is 1. So effectively, all you're going to do is put a over 2 for all 5, and then square root and go up in ones. So square root 0, square root 1, 2, 3, 4. Okay? Now cosine is also pretty nice. If you want, you can do the same method, but you're doing it backwards. It's a count down. Okay? So you're going to be doing square root 4 over 2. You literally do the exact opposite. And can you see I'm just counting down? So in the first one, I'm counting up by ones. In the other one, I'm just going down. Or if you've already written out the other ones, you can just literally copy it from here, right? And 1 over 2, because it's just square root 1, and then that would be 0. Cool. I will say that as you use these more and more, I would recommend having them written down in front of you on a little post-it note or something. And then when you're doing any trig questions, just instead of using a calculator, try and, if you know that it's 0, 30, 45, 60 or 90, just try and refer to that sheet instead. Now tan is a little bit of a more difficult one. Now you might notice that I might actually give you more than what you need. Here's the hint. Tan is equal to sine over cos. So all I'm going to do is I'm going to divide these two things. So 0 divided by 1 gives me 0. A half divided by root 3 over 2, it just flips the fractions, right? You change that to a times. equals 1 over root 3. Okay. Does this take a bit of time? Absolutely, but it's kind of guaranteed. Root 2 over 2 divided by root 2 over 2 is 1, right? Root 3 over 2 divided by a half will just give me root 3. Again, for the same reasons. Root 3 over 2. We keep change flip, so that would be times 2 over 1. So then that would just become 3. 1 divided by 0 is just undefined, okay? So you didn't actually need the 91. So I will say that a lot of them, so this one and this one are pretty easy. And then you can kind of remember it as it's 1 over root 3 and then it flips to root 3, however you want to remember it. But these first two, if you can use this trick to remember them, it means you'll always be able to work out the tan version. Because keep in mind, you'll only ever really be asked one of these, like, how many are there? 15 values, right? They'll only say, use the fact that sine 30 equals something, right? Or they'll give you a trig question and it'll say cos 60 equals x, what's x, or something like that. So they'll only ask for one of these values, so there's a much bigger chance of you being asked sine or cos. But again, that means if they do give you tan 30, you can work out sine 30 and cos 30 and divide it to get what tan 30 is, okay? So it is possible, you don't need to memorize it, except this trick. Higher here, you need to be able to use the sine and cosine rule to find unknown lengths. So with the sine rule, it's very difficult to know when to use sine versus cos rule. Generally speaking, cos rule is if you have two sides and an angle between them, or you have three sides and you want an angle. It's a bit more tricky. However, with practice, you'll know when to use them. So this one, immediately I'm thinking sine rule. Why? Because I have an angle and its opposite side, and I have an angle and I want its opposite side. So in this case, it's literally just going to be, and if you want the opposite side, I would recommend doing the side on top. But keep in mind, if you want an angle, you can actually flip the sine rule over. So there's no harm if you're working out an angle just doing sine A over A equals sine B over B. So that's one of the powerful things with the sine rule. It's equally easy if you want an angle or a side. The rearranging is actually identical. It's just that you need to change which equation you use. And that would just be 13 sine 38 sine 100. Okay, and you'll enter that on your calculator. Again, remember to always use brackets and things like that. So we have 13 sine 38. It actually opens brackets for you, so that's nice. Over sine 8.13 centimeters. Well, it actually says to one decimal place, so 8.1 centimeters. And with the cosine rule, if you look, I have two sides and the angle between them. And what the cosine rule basically says is the opposite side squared to the angle is always equal to the sum of the other two sides squared minus 2 times the sides multiplied together cos the angle between them. Okay, so again, what I would do, and this is my personal preference, is whatever angle I have or want to work out, I call it A. Right? And the reason for this is that there are some schools and some things on the internet that will say you have to memorize 3 different cosine rules. One if you want to work out A, one if you want to work out B, one if you want to work out C. You don't. That's a load of nonsense, right? All I would do is whatever angle I have or want, I label that A, and the rest of the labeling doesn't matter, right? All you need to is make sure the side opposite is also lowercase a. The other two sides don't matter. Because think about it, all I'm doing is adding them or timesing them. You can add and times in any order you want. And then here is the formula for the area of a generic triangle, half AB sine C. Okay, so again, if you don't have a right angle triangle, you actually do need to use this formula. So the area in this case is just a half. So where does the AB sine C come from? Well, A and B are just two sides and C has to be the angle between them, okay? So as long as you have an angle and sides next to the angle, you're completely and utterly fine. Okay, so again, doesn't really matter what you call the letters, you just need two sides and the angle between those two sides. You also need to be able to describe translations as 2D vectors. So vectors aren't just those scary things at the end of like paper 3 or paper 2. They are actually used for translations. The top number tells me how far right or left I go. The bottom number tells me how far up and down I go. Positive numbers means right and up. Negative numbers means left and down. So we're going 3 to the right, not left, and we're going 2 down, not up. So all I do is I take each point and I just go 1, 2, 3, 1, 2. Right? Take the next point. 1, 2, 3, 1, 2. And once I know exactly, I know that this last point is going to be 3 points up, right? And then I'll just join all the points together. I'll do it just for the sake of completion. Like that. Perfect replica right there. You also need to be able to add and subtract vectors and also multiply them by scalars. And for higher tier, you need to also do proofs, which is fun. So write these as a column vector a plus b. When you add vectors, it's actually quite pleasant. All you do is you add the top and bottom numbers. It's not like fractions where you have to make the bottom number the same. All you need to do is add the numbers. So 2 plus 1 is 3. 3 plus 5 is 8. Now what about multiplying them? So when you have 2 times a plus 3b. Well, again, it's actually quite pleasant. All you need to do when you multiply by a scalar is you times both numbers by the number outside the bracket. So it's 2 times 2, which is 4, 2 times 3, which is 6, plus 3 times 1, which is 3, over 5 times 3, which is 15, and then again we're adding the numbers. Easy. It says here points, this vector C is drawn here. So as I can see, the vector is just 2 to the right and 1 up, so that's 2 and 1. And it says draw the vector 4C. So if I wanted to work out what 4C would be, it's going to be, equals 4 times 2, which is 8, 4 times 1, which is 4. So I need to draw something that goes 8 to the right and 4 up. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So there, and then it would be a straight line joining them. That's it. The only other thing, by the way, is I've underlined it because C is a vector, so we tend to underline vectors. If you notice, they actually write them in bold, but I can't write in bold, and neither can you. So unless you're typing it, which would, possibly, I would recommend underlining it. Probability, probably one of the scary topics. All you have to do, I'll go through this quite slowly, but the first one, there aren't many points, by the way, in this. It's just that probability really sucks. Record, describe and analyze the frequency of outcomes using tables and frequency trees. This here is a frequency tree. So it says 30 people took a literacy test and a numeracy test, and 23 people passed the literacy test. Okay? So, in total, if you look here, how many people took it? Well, 30 people took a literacy and numeracy test. And then it says, how many people passed? Well, 23 people passed, which means 7 people must have failed, right? So think about it. The good thing about frequency trees is if you look along these, this 30 is being split up into 23 and 7. So what that means is that these two numbers have to add up to 30. So if I use this logic in the top branch of the tree, this 23 is being split up into 21 people who passed and some number of people that failed. Well, think about it. This must be 2 then, because these numbers should add up to 23. Likewise here, 7 people failed and they're split up into 3 people who failed the numeracy test. And how many people passed? Well, it must be 4, because this 7's being split up into those 2 numbers. Okay, it needs to still add up to 7. Apply ideas of randomness, fairness, equally likely events to calculate expected outcomes of multiple future experiments. So calculating expected outcomes, something like this, right? All you need to do is you take the probability an event will happen and you times it by the number of times that they're doing the experiments. In this case, they're rolling the dice. So times it by 200. So 0.3 times by 100 is 30, times 2 should be 60. So it should land on 6, 60 times. That is the expected outcome. It doesn't mean that this will guaranteed happen, right? Like I could flip a coin. If I flipped a coin 4 times, you would expect me to get 2 heads and 2 tails. But it's possible for me to get 3 heads and 1 tail, or no heads and 4 tails. So again, this is expected, it's not guaranteed. Okay? So randomness and fairness, well, when something's random, it means that the probability, you can't determine it, right? Fairness means that all outcomes are equally likely. So when I flip a coin, it's equally likely I get heads and tails, hence it's fair. When I roll a normal dice, an unbiased dice, it's equally likely for me to get a 1, 2, 3, 4, 5, and 6. So again, whenever they say work out an estimate, and they've given you a probability, all you're doing is taking the probability and timesing by how many times they're doing whatever they're doing. Rolling a dice, flipping a coin, pulling out hats from like something from a bag, whatever. Okay, you take probability times by the number of times you do it. That gives you an estimate for the number of times that event will happen. Okay, so you need the probability that it lands on a 6 times by the total number. You should also relate relative expected frequencies to theoretical probability. So theoretical probability would be, again, something like when I do flipping a coin, the theoretical probability of me getting a head is 0.5 and the theoretical probability of me getting a tail is 0.5. Now, if I flip a coin 100 times, right, it's, again, theoretically I get 50-50. But what if I got 60 heads and 40 tails? Okay? The expected frequency is just the probability I get a head based on experiment. So it'd be 60 out of 100, which is 6/10, right? Which is 3/5. So the theoretical probability is a half, but my actual result shows that the probability is 3/5. Okay? So when it says relate them, the relation is that as I increase this number up here, I will get closer and closer to the theoretical probability. So this is where it's a bit weird, right? If I flip a coin 10 times, it's actually not that likely for me to get 5 heads and 5 tails, right? Even though theoretically I should. If I flip a coin 100 million times, my probability is actually a lot closer to 50-50. Okay? So in general, the expected frequency will get closer to the theoretical probability as you increase the number of trials. And what is the probability scale from 0 to 1? Well, probabilities are a decimal between 0 and 1. 1 means it's guaranteed, 0 means it's physically impossible. So let's say I have a coin that has heads and tails, and I say, okay, what's the probability of me getting a head or a tails? 100%, it's 1, because it's guaranteed that I get either a head or tails. Okay, and what's the probability that I get a triangle? 0, because there's no triangle on a coin, okay? Apply property that probability of an exhaustive set of outcomes. Okay, that's very fancy. But basically, all this is saying is all probabilities add to 1. Okay? So what does that mean? Well, if you look at this question on the right, in a bag there are only red, blue and white counters. Okay? So this is the exhaustive set they're talking about, right? I don't care about yellow, green, turquoise counters. I only have red, blue or white. So if I put my hand in a bag and I pull out a counter, the only possibilities are that it's red, blue or white. No other colour. So logically speaking, right, the probability of getting red plus the probability of getting blue plus the probability of getting white should add up to 1 because it's guaranteed, so it's 1, right, that I get one of the 3 colours. Yeah? So to work out the probability of getting white, all I'd do is do 1 minus 0.5 and 0.3, which is 0.2. The other way to do that, by the way, is to add 0.5 and 0.3 together and then subtract that from 1, right? So 1 minus 0.8. Cool. And then again, we did speak about this a bit earlier, right? If it's, again, assuming that your experiment's good, as you increase sample size, your actual empirical probability will approach the theoretical probability. So a question that they normally ask is, you know, this person's doing an experiment, right? They roll a dice 1,000 times and they get this many 1s, 2s, 3s, 4s, 5s, and 6s, or they flip a coin 100 times. How can they get a more accurate answer? The answer is always increase sample size. That always works as your answer because it will always make your answer more accurate because it will approach the theoretical probability. You also need to use Venn diagrams using sets and things like that, and also tree diagrams. So here we go. 40 students were surveyed. 20 visited France, 15 visited Spain, 10 have visited both France and Spain. Complete the Venn diagram. So here's what I do. I always start from the last piece of information, which is the overlap. So if there's 3 things, it will say 10 have visited France, Spain, and Germany, or whatever. So that gives me 10 in the overlap. So I've used that piece of information. Now it says 15 have visited Spain. I do not put a 15 here. Okay? Because think about it, right? 15 people have visited Spain. That includes the 10 people who have visited France and Spain. So everything in this circle should add up to 15. So this should be 5. 5 people have visited only Spain. 10 have visited France and Spain. So that gives me 15 people have visited Spain in total. Same thing with France. Everything in this big circle here should add up to 20. Okay, I'm done. Nope. 40 people were surveyed. 10 plus 10 plus 5 gives me 25, which is not 40. That means everyone else didn't visit France or Spain. So there's going to be another 15 people, because 15 plus 5 is 20, plus 10 is 30, plus 10 is 40. Every number inside your Venn diagram should add up to the total number of people. So in this case, all of my numbers should add up to 40. Okay, Tina has 2 bags of counters, bag A and B. She has 5 red and 3 blue in A, 4 red and 5 blue in B. She takes a random counter from each bag. Complete the probability tree diagram. Okay. So first of all, with bag A, there are 5 red and 3 blue. So the probability of getting red is 5 reds out of how many in total? 8 counters. Now, probabilities, a long tree should add up to 1, which makes sense, right? The probability of getting blue is now 3 over 8, and they do add up to 1. In bag B, okay, cool. We have 4 red and 5 blue, so it's 4 out of a total of 9, and therefore that's 5 out of a total of 9, and it'll be the exact same down here. And it says work out the probability that Tina takes 2 blues. Well, it's going to be this probability followed by this one. As you go along a probability tree, you multiply, okay? So that's going to be 3/8 and, so times 5 over 9, like that, okay? So that'll be over 72, 15, okay? Which you can simplify to 5 over 24 if you'd like. So again, across branches should add up to 1. Along branches you always multiply. Construct theoretical probability spaces for single and combined experiments with equally likely blah blah blah. Cool. Helen takes a card at random and she does not replace it, and then she then takes another card. Calculate the probability that both cards have the same number. So here are the possible outcomes. She takes 1 and a 1. Right? She takes 2 and a 2. She takes a 3 and a 3. Now, here's the key thing. This is the 3 possible ways she could have 2 cards of the same number. So my total probability, I would have to add these up, right? Because the probability she takes 2 cards of the same number would be the probability of getting 1 and 1 so essentially I'm going to use the word or. So probability of getting 1 or 1, or 2 and 2, or 3 and 3. And when I say or in probability, I mean add, okay? So probability of 1 and 1, add the probability of getting 2 and 2, add the probability of getting 3 and 3. So let's work that out. So what's the probability of getting a 1 straight away? Well, there's 1 card, and there's 7, well, there's 2 ones, right? And there's 1, 2, 3, 4, 5, 6, 7 cards in total. So it's 2 out of 7 to pick a 1 at first. Now she doesn't replace the card, so she has this 1. So let's say she took this 1 here. Yeah? What's the probability of getting another 1? Well, there's only 1 1 left. And there's 1, 2, 3, 4, 5, 6 cards left. Do the same thing for 2 now. So what's the probability of getting a 2 at first? Well, there's 2 2s out of a possible 7. When I've taken a 2, there'll only be 1 2 left out of 6. right? Because again, I'll take one of the 2s and then there's only 6 cards remaining. Lastly, how many 3s are there? Well, there are 3 3s, so it's 3 out of 7 at first. And then I've taken one of the 3s away, so now there's 2 out of 6 3s. And you'd add those all up, okay? Again, if you ever get a fraction that's bigger than 1, you know you've done something wrong. So let's work this out. We have, it's a bit tedious to put on a calculator, but oh, kind of hard. Keep in mind I'm using a keyboard and mouse to do this. It's taking me a lot longer than it should. On an actual calculator, I can do it a lot quicker. But I want to show you guys how to enter this in, because remember, I'm using brackets, and even when it's very painful for me to type it in, I'm still using brackets because you can make easy mistakes, and your calculator might do something a bit stupid if you don't put brackets on there. Gives me 5 over 21. Which is not that likely, which does kind of make sense. Part 8. Calculate the probability of independent combined events using tree diagrams. So again, you're going to do the exact same thing with a tree diagram, and then you just need to work out probabilities. We have done a question exactly like this before, so feel free to pause the video and have an attempt. Calculate and interpret conditional probabilities using two-way tables. So two-way tables look like this. So we need to be able to work out what these gaps are. So completing it is quite interesting. So these total here shows me that 52 plus something gives me 100, so that must be 48. Now everything along this length should also add up to 48. So 22 plus 8 is 30, so that means this must be 18. So now I can work out this value here. 15 plus 18 is 33. 33 plus 19 plus something gives me 100, so 33 plus 19 is 52, so we need another 48. So that means that must be 26, and 15 plus 26 is 41, so I need another 11 here. Nice. One student is picked at random, write down the probability that they walk to school, so you take the total here, 33 out of 100, which I wouldn't simplify it to a third, although you can argue it's a third. And that gives us to the last topic, which is statistics. We're almost at the end of the video, thankfully. This has been pretty long. I mean, I'm pretty sure you can see the lighting change in my room because sun's setting and clouds and stuff. So S1, the first thing you need to be able to do is infer properties of populations or distributions from a sample, whilst knowing the limitations of sampling. So I'm going to go through what the limitations is. I can't really give you a good example of the properties because it's so different every single time, right? But the limitations is always that the sample may not be representative of the overall population. Okay, so the idea is that the sample is too small. The best sample is everyone. Okay, so whenever you see questions like that, where it's like, what are the limits or how can it make it better? Increase sample size, and the reason is that the sample may not be representative of the population. Here you need to be able to construct various different diagrams and charts and stuff. So I think the hardest one is probably pie chart. So what did Fiona spend the most money on? Rent and bills. What fraction was on transport? Well, it's 90 degrees, so it's a quarter. She spent £320 on transport, and we know that that's a quarter of her total budget. So 4 times that is her total budget, which is £1280. So how do you draw a pie chart? Well, again, I won't be able to draw it because you need a protractor, but I'll tell you the method. Here's what you do. You add up all 3 of these numbers, okay? So 58 plus 33 plus 29, 120. And what you want to do is work out how many angle, or like what degree does each person get. Because keep in mind, we have 360 degrees in total. So these 360 degrees need to be split between 120 people. So each person will get 3 degrees. I will then add another row or column, depending on how it's laid out, called angle, where all I'm going to do is times each of these numbers by the angle each person gets. So 58 times 3 gives me 174. 99 degrees, and then 87 degrees. To check your answer, I would recommend adding these three values together and making sure you get 360. And then all you need to do is actually draw the pie chart. So you would put your protractor along this starting line, where it will be 0, and you measure out 174, which would be something along the lines of this. Again, this is not accurate for French. Then you put your protractor along the line you just drew, and you measure out another 99 degrees, which again is going to be something vaguely like this. Now you don't actually need to do the last one, because it's just going to be what's left. But what I'd recommend doing is putting your protractor along this line and measuring 87 degrees and seeing if you get back to your starting position, okay? You need to be very accurate. But remember, your 0 line is just the line that you've just drawn, starting from this line. So 0 is here, then you move it over to here to draw German even, and along here to do Spanish. Now, if you look here, the pie chart below shows information about the languages studied by Year 11 students, and Maggie says it shows that more students study French, right, at school B. So if you look, it would be more, right? Well, not quite. Is she right? The answer is no. Pie charts do not tell you how many people study something, right? All it tells you is what fraction of people study it. So here, over half the students study French, and here just under half the students, right? But how do I know how many people are in Year 11? There could be 100 people here and 500 people here. So just under half of 500 is 250, just over half of 100 is, let's say, 60. So more people are actually in the first one. So here's the hint. If they ever ask you this, you can't tell, because pie charts show you proportion, not numbers of people. You also need to be able to do histograms. Okay, how do you work out histograms? You add another column standing for frequency density, FD. To work out FD, you take the frequency and you divide it by the class width. Okay, so you're going to be doing 20, and the width of this class goes from 20 to 30, so it's divided by 10. Right? That's 2. The next one, the frequency is 22. The class width goes from 30 to 35, so you divide by 5. 4.4. Next one, 16. Divided by the width, which is 5. 3.2. 13 divided by the width, which is 10, which would be 1.3. And 9 divided by the width, which is 15. I can't really do that in my head. 0.6. Okay, I probably could have done that in my head. Okay, now for a histogram, the height, if you want to call it that, the y-axis is the frequency density, and this would just be whatever your thing is. So in this case, it's age, right? And I'm going to start at 20, and then if you look each big one, it needs to go up to 65. So 30, 40, 50, 60, 70, that works perfectly. So every big square I'm going to do is 10. So that means each half square is 5. I need to go from 0 all the way up to basically 4.5. So I could go up in 0, 0.5, 1, 0.52, 0.53, 0.54, 0.5. Okay, so I can literally go up in 0.5s. So I'm just going to call that 1, 2, 3, 4, 5. And here's how it works. You plot off the frequency, but you only go up until the max class width. So you might notice that all of the bars will be different widths, like you can see over here. And the height, so the area is proportional to how many people you've got in here, right? So again, the next one, it's only 5, so it's actually only going up to here in terms of width. But it goes all the way up to 4.4, which is, so that's 0.5, it would be 0.1, 0.2. Again, you would need a ruler for this. And if you notice, I'm actually drawing it coming off the coming off the previous bar. 35 to 40 all the way up to 3.2. You see the look of concentration on my face. 40 to 50 goes up to 1.7. And again, I've done a lot of these topics in my live lessons, which are uploaded on YouTube, so I recommend going back and watching them. And lastly, 50 to 65 is 0.6, so it'll be one above the halfway mark. Like that. Looks hideous, but yeah. So again, it should look, well, I mean, this isn't the answer, obviously, this is a different kind of histogram, but we'll go through this one as well. Shows the information about weight of pigs, whatever. 30 pigs weigh between 50 and 65, so between 50 and here. Right? Work out an estimate for the number of pigs that weigh more than 80 kilos. So what you do here is you need to work out what the frequency density is. So you're doing 30 over 15. So you know that this height is 2. So each square looks like it's going up in ones. Right? Like that. And we need to work out an estimate for the number of pigs that weigh more than 80. So all you do for that is you do the class width. So in this case from 80 to 85 times the frequency density, which is 4. So 80 to 85 is 5. So 5 times 4 is 20. So there are 20 pigs between 80 and 85 kilos. And then you're going from 85 to 100, which is 15. So 15 times the frequency density, which is 1, which is 15. So in total there are 35 pigs above 80 kilograms in weight. There's some chunky boys. You also need to be able to work out a bunch of averages and also plot box plots. So here are the box plots. How do you do a box plot? Easy. The only things you need are the smallest value, the biggest value, and the 3 quartiles. So here's how you do that. So again, you're going to draw a line at 9, a line at 15. I tend to make it a bit smaller just to make it a bit more obvious that it's a box. 19 is the median. Again, using a ruler and a pencil would be way easier for this, but what can I say? There you go, that's my fantastic drawing. And this is compare the distribution. So what do you compare? You compare the median. So on average, people in class B scored higher than class A, because look at this line. It's further to the left. That's one set of marks. The second set is for doing spread. Okay? Now you don't use the range. You use the interquartile range. So you look at this number here, 31 minus, I think that should 15, which is 16, right? So the interquartile range for the first one is 16. Interquartile range for the second one is, so it goes from 12 to 30, which is 18. So the spread for class B is bigger than the spread for class A. There you go, that's your full 2 marks. Interquartile range, compare. Median, compare. And then working out from just a normal list of numbers, the range, mode, and etc. Range is just the biggest minus the smallest number, so 7 minus 2, which is 5. The mode is the number that appears the most, which is 4 in this case. There's 3 4s. The mean, you add them all up, and you divide by the number of numbers you have, which is divide by 10. You just use a calculator. Again, range, biggest minus smallest. Median is the middle number, so you write the numbers in order of size. This has already been done for us, and then you just kind of find the middle. So I like to cross them off one by one, circle it, and again the mean's the same. So applying statistics to describe a population, it's very similar to what we did with the box plots. You want to look at the average and you want to look at the spread. Average, you can use mean, median, or mode. Normally you use mean or median. And for the spread, you use range or interquartile range. Lastly, use and interpret scatter graphs of bivariate data. Bivariate means that you have 2 variables, so biology and physics in this case. And recognize the correlation and know it does not imply causation. Draw estimated lines of best fit, make predictions. Okay, cool. So what type of correlation? Well, if when you draw a line of best fit, right, it's not bad. If the line goes up, it is positive. In this case, it goes up. If the line goes down, it's negative. And if the line is basically horizontal, there's no correlation. Another student scored 52 marks on their biology test. Estimate their physics score. What you do is you look at where 52 is on your graph, on your x-axis. You would go up until you touch your line of best fit, and then you'd read across to estimate their physics score. And that is the end of AQA GCSE Maths. Edexcel, you'd also kind of benefit from this as well. But good Lord, we are finally finished. Best of luck on your exams.